All right, welcome everyone. Glad to have you here on this first edition of the virtual MLNet Community Conference. It's really crazy to see that um, all the long wait time here to get it started is finally over, and we are here. We have two fantastic days of content. The first one with today with workshop material, and the second one tomorrow with a full day of sessions with speakers from honestly 6 different countries and 5 continents. We have Australia, we have New Zealand, we have India, we have the US, we have Mexico, and we have Holland, which is really cool. But with me today, I have one of my co-organizers here, John Wood. John, would you like to introduce yourself?
Yeah. Let's see. Man, I've been with ML.NET since I think it first got announced and built. What was it? 2 years ago, I think. Is that right?
Yeah, I think that's right.
Yeah. Yeah. So I've just been kind of messing around with it and just having fun, pretty much.
That's awesome. Well, myself here, my name is Alexander Slotte. I'm based out of Washington, D.C. and the East Coast. I'm a Microsoft MVP, and I've been in love with MLNet for about a year and a half now. And just it's a fantastic framework. And I'm so happy that we can kind of build a community around this, and we can have you all here watching as well. And we hope that you will enjoy today and tomorrow. But before we get started, we do want to take a moment to thank our sponsors, Excella and Vintellect. Excella is an agile transformation organization here in Washington, D.C. That's actually my employer. And we are about 300 people strong, and we love .NET. So if there's anything you need help with when it comes to .NET, definitely don't hesitate to reach out. And John, would you like to introduce Vintellect?
Yeah. Well, Wintlet is kind of similar to Excella. It's a consulting and training company. They do websites now, but they kind of do anything Microsoft related, a lot of Azure stuff as well. So yeah, definitely hit them up. They do webinars pretty much every couple of weeks, and those are free. So definitely look at those.
Fantastic, yeah. And John here has gotten us these amazing shirts here that you will see along the conference here. I love ML.NET, and if you want a T-shirt, I think John is going to try to organize something so everyone can order them as well. So we'll kind of stay tuned for that, and you will learn more in a bit. But some things to keep in mind during today and tomorrow as well is that if you have questions during any of the talks, definitely ask them in Twitch or in the YouTube chat, or you can also join our Slack community and ask them in whatever channel you want there, and we'll be monitoring them. Throughout the workshop today, me and John will try to assist Bree and Louise and make sure that things are working smoothly. But yeah, we will have so much fun content, so I don't want to take any time away from this workshop that we'll be having right now. So let's bring in Bree and Louise. Good morning, Bree and Louise. How are you doing?
Hey, how's it going?
Good. We are super excited to have you with us today. Thank you so much for doing this workshop for us in the community. I've seen the content yesterday night, and I'm really excited myself just to follow along. Is there anything you would like to share with the audience here before we get started?
Louise, anything?
Yeah, yeah, no. I mean, if anything to share, we just wanna. We hope that you guys enjoy the content that we have prepared for you. We worked pretty hard to get this together, and you know, with your help as well, organizing this, and we're just really excited to be here, and we hope that by the end of the conference, you know, all of our attendees are inspired, and they basically take what they've learned over the next 2 days and go back to their companies, or you know, just in their personal projects, be able to sort of start using ML.NET on a more regular basis.
Cool, that's awesome.
I hope everyone has fun and learns a ton. And then at the end, we really would love to hear all your feedback as well and all the things that you do with ML.NET.
That's perfect. And it's a great segue as well, Bree, because we have a feedback channel on Slack. So if you have any feedback to Bree, who's the program manager for ML.NET, or anyone else in the team, you should definitely just put it there. I've already put a lot of my feedback there, and I encourage everyone else to do the same. And a final note as well is that the Slack channel, the Slack community, is going to persist after this conference is over. And we hope that that will evolve into something where we can all connect as ML enthusiasts and get around different ideas, whether that be open source tools, startup ideas, or just speaking and learning together. let's do that and let's build a community together. I'm really excited about that. So stick around. But I know we have a really, really impressive and amazing workshop lined up here. So I am not going to spend much more time. I'm going to give it over to Bree and Louise. So take the day away, guys.
Awesome. Thanks, Alexander. Switch over to my deck here. Awesome. So welcome everyone who's tuning in for the workshop. We're really excited to teach you a lot about ML.NET. And as a quick intro, my name's Bree. I've been at Microsoft about 3 years now. I've been working on ML.NET for about a year. And I'm a PM on the team. And Louise, would you like to introduce yourself?
Yeah, absolutely. So I'm Luis. I'm a content developer at Microsoft. I'm working across various AI technologies like ML.NET and Azure Machine Learning as well. I've been at Microsoft for a little bit over a year. Prior to that, I was in consulting, and I'm based out of the New York area.
Awesome. So to go over a little bit how the format will go of this workshop. So we are streaming on Twitch and YouTube. So hello everyone on those two channels. The way that it'll work is you'll learn first. So we'll have slides to teach you about machine learning, about ML.NET, and then you'll have tasks at the end of each, essentially each section, and you'll start building your app and putting it together. We'll go over what that app will be a little bit later. And feel free to ask any questions over Twitch, YouTube, or the Slack channel. I put the link, a short link to the Slack channel right there. And again, you can leave feedback in the Slack channel as well. And we'll have Alexander and John moderating, so hopefully they'll be able to answer any questions. And then at the end of each section, we'll try and pause and answer any questions that you may have as well. All right, so here's the agenda. We'll be talking about what is machine learning, a brief introduction into ML, talking about the basics of ML.NET. We'll have a little challenge for you all. We'll have the setup for the rest of the projects or the app that we'll be building. We'll talk about data, training, evaluating, saving models, consuming those models, a little bit about deep learning and MLOps, and then we'll wrap up with the roadmap for ML.NET, some resources to get you started or keep learning, and then a final Q&A. So this slide here is the prereqs that you'll this workshop. The project repo can be found at this short link, aka.ms/MLNet workshop. And if you're on Windows, you'll have to have VS 2019-16.6 with the .NET Core workload installed and the model builder preview feature enabled. And if you're on Mac or Linux, because ML.NET is cross-platform, you should have VS Code or your favorite editor, the .NET Core 3.1 SDK, and then the ML.NET CLI, which right now can only be used on .NET Core 2.1. We're about to upgrade, but didn't quite make it in time. And all of these are going to be at aka.ms/mlnet-prereqs. So if you don't capture this now, that's fine. You can go to that AK link, which you can also get through to from the repo for the workshop. And so while we're going through these first two sections, make sure that you're getting all these prereqs done so that we can get started into the app really, really quickly. And with that, we'll start with our first, what we call phase or section. So we'll start off with what is machine learning. So to start off, we'll actually talk about artificial intelligence. So artificial intelligence is the ability of a computer to perform tasks that are usually associated with humans or intelligent beings. This could be things like reasoning, generalizing, and essentially it's machines imitating human abilities and behaviors. So AI usually starts as a rule or logic-based system, and this can actually be difficult to scale sometimes. So as an example, we've got bread and not bread. So with traditional AI techniques, you can see that it would look something like this. You'd have a bunch of if statements, and this can be really, really hard to scale. First, because there's so many different features that bread versus not bread can have. And then when you start thinking of, well, is rectangular? What does that actually mean? So it can really be hard to scale. And that's where machine learning comes in. So machine learning is getting computers to make predictions without being explicitly programmed. So what happens is computers find patterns in past data. They learn from that data, learn from that experience, and then they act on new data to make predictions. So this is used to solve problems that may be difficult to solve with traditional AI. So as an example, if we're looking at that bread versus not bread, Instead, what would happen is you'd have a lot of different examples of bread, a lot of different examples of not bread, and then you would create a model that would then learn from these past examples to then be able to decide, are these images bread or not bread, these new images. All right, so just another way to think about it, if we're looking at artificial intelligence, the input here is going to be the rules, like those if statements and the data that you have, and the output is going to be the answers, bread or not bread. Machine learning, on the other hand, you're going to give it data and you're going to give it the answers, and it'll learn and then give you the rules that you can then apply to new data. So then we've got deep learning. This is a subset of machine learning based on artificial neural networks. So what these do is it imitates the way the human brain learns, thinks, and processes data. So these neural networks form a lot of different layers, so it's a bit more complicated than your traditional machine learning scenarios. But these can include things like image classification, object detection, natural language processing, and so on. And how these all fit together, you got artificial intelligence, you got machine learning, which is actually a subset of artificial intelligence, and then deep learning, which is a subset of machine learning. So this is just a visual so you can understand how it all fits together. Right. So when we're mapping business problems to what we call machine learning tasks, you first want to find out what is the problem you're looking to solve. So for instance, if you want to find outliers in data, you could use anomaly detection. If you want to predict a number or value, you could look at regression or forecasting. If you want to find relationships between data, you can try the clustering task. If you want to categorize items, we've got classification. Binary classification is when you have two different classes, such as yes or no, or true or false. Multi-class classification is when you have a lot of different classes, or at least 3 or more. And then you've got image classification. If you want to make suggestions, you can take a look at the recommendation task. And I'll go a little bit more in depth in these a little bit later. All right, so then we've got the machine learning workflow, and I'll actually hand this off to Louise to start talking about the machine learning workflow.
Awesome. Thanks, Bree. Okay, so in terms of the machine learning workflow, it really is a workflow. It's a series of steps, right, that consists of both model training and model consumption. Now, as part of the model training, there is the first step, which it all starts with the data, right? Like you need data to be able to train your machine learning models. You need data and examples to be able to try to make sense of what's going on and build a model around that. Then what you want to do is you want to prepare the data, and part of preparing the data, it means several things, right? So this means that you are cleaning up the data, you are making sure that the data is evenly distributed. And once you have your data prepared, you want to go ahead and you want to train the model. So you want to choose some sort of algorithm, sort of like the ones that Bree was mentioning earlier, choose a task and choose an algorithm that's going to train a machine learning model based on your data. However, once you've trained the model, you got to know, well, is it performing well, or is it doing what I expect it to do? And that's kind of where you have the evaluation phase. And finally, if you feel good about how your model is performing, you essentially then move on to the deployment phase. Now, notice how the prepare, train, and evaluate, there's sort of a loop that's there. And the reason for that is that it's very experimental, because it may be the case that the model is not, you have to go back to the drawing board and you have to see, can I add more data? What can I do to improve my model? And so once you've done that and you're happy with your model, you've deployed it, now it's time to inference or to make predictions, right? And this you can do from basically any kind of application, whether it's desktop, web, or mobile. Okay, so when it comes to getting and preparing the data, one of the first things you got to think about is your data source. Where is my data going to be coming from? Now, this is going to be either from a database or it's going to come from files, right? So that's certainly top of mind when you're building and preparing your data, right? The next thing that you want to think about is what's your pipeline going to look like? As you're collecting your data, is your data going to be collected, or are you going to process your data in a streaming fashion, right? So near real time or real time. Or are you going to do batch processing, where you have large bulks of data that you process once at a time, right? Then the next thing that you want to think about is the environment. Where is my application and my data going to live? Do I want it to live on premises? Do I want it to live on the cloud? Where will my data be stored, right? And then the next part that you want to do is you want to do some data exploration, right? So you want to do some visualization, you want to do some cleanup, you want to do some validation to make sure that the data is accurate and it's correct, right? Because the data that you want to give to your model, right? It's garbage in, garbage out. If the data that you're feeding to your model isn't good, or it's got missing values, then you're not going to be able to get a fairly good model to make sense of, right? So what does preparing the data mean? In this phase, what you have is you have data exploration, as I mentioned. And what you want to do as part of the data exploration process is you essentially want to kind of get a sense of what's the distribution of your data. Is my data evenly distributed? Are there more examples of perhaps one set of categories, or to see what are the ranges? For example, if you're looking at age, what's the distribution of the age across my set? What's the minimum, maximum? So do some very basic sort of data exploration and descriptive, get some descriptive statistics around your data set to get a better sense of what is being represented in your data. The next step is data cleaning, right? So kind of going back to that thing that I was mentioning around garbage in, garbage out. You want to make sure that your data is clean. And what I mean by data is clean is, you want to remove your null values. Perhaps there is sensitive information, there's private information that you cannot use as part of your models, or that it doesn't contribute to your model. So you want to make sure that all that stuff is sort of clean out, and you have a nice clean data set as your starting point. And then the other thing that you want to do is you want to do visualization. So visualization, it serves two purposes. Number one, again, it kind of goes back to the data exploration piece where you're able to visualize what your data looks like. But at the same time, it also serves sort of as a communication mechanism, or a way to communicate to others what your data, and tell stories about your data, right? So that serves two purposes. So if we go on to the training the model phase, now that you've gotten your data, you have prepared your data, you've cleaned it, now it's time to train your model. So what does training the model mean? Well, if we take a look at this table here, for example, what we're trying to determine, let's imagine that you're in school or you're taking a course, such as this one, and you want to know whether you passed or you failed, right? Just yes or no. And how are you going to determine that? And so what you're trying to determine what the label or the target value is, right? That's the value that you're trying to predict. So how are you going to be able to do that? Well, you have inputs or features, right? In this case, you're taking a look at what was the previous grade or the mark that a student received in this course, and you're looking how many hours have they studied before the test. And using those inputs or features, you're going to try to come up with a function that takes in the previous grade and hours studied to determine whether a student passed or not. And that essentially is your model, right? Your model, you can think of it just like a function that contains some sort of saved internal state, right? In this case, it's sort of it's recognized the patterns that your data, the examples that you gave it as part of your training phase, and made some sense of those patterns to create an internal state that works like a function that takes inputs. Again, in this case, it's a previous grade and hours studied, and it tries to give you an output or an answer. In this case, whether the user passed, the student passed or not, right? And that's your model. So in the evaluation phase, now that you have a trained model, you want to get a sense and understand, how is my model performing? And there are several ways that you can do this, right? Depending on the task, kind of like Bree mentioned, whether it's regression, classification. The metrics differ, but at the end of the day, most tasks do have a way of measuring how well is your model performing. And a way to evaluate whether you have a good model or not is through these evaluation metrics, right? However, that's not the only way that you can evaluate models. One way that you can evaluate models is how easy are they to explain. Now, for example, you may have a model that is really, really good at making predictions, but if you have no idea why it's making the predictions that it's making, is this something that you want to use? For example, if you're in the medical field and you are diagnosing some sort of disease, right? You want to be able to understand, why is my model diagnosing my patients with a specific disease or condition? And you want to be able to tell, what are the symptoms and things like that. So if you have black box models where you can't explain them, maybe it's not something that you might want to use, and you might give a little bit of accuracy. You might trade a little accuracy for something that's a little bit more explainable. And then the last part is training effort, right? So for example, going back to that sort of same metric in terms of like how, if you have this model that has evaluation metrics or accuracy, and it's predicting fairly accurately, but it takes a really long time to train. Let's say it takes 2-3 weeks, and it takes a long time to prepare your data. It takes a long time to get to the process of building your model, right? So at that point, you kind of have to question, is there another model, a simpler model that I could use that might still give me just as good of a result, but it's going to take less effort to train, right? So as you're building your models, these are some things that you think about. So evaluation metrics are certainly useful, but looking at it across these other sort of looking at across these axes of explainability and how hard is it to train a model also should be something that you consider. And in terms of deployment, so deployment typically happens by you serializing the model. So once you've trained your model, you have this thing that allows you to give it inputs, this function that allows you to give it inputs and produce outputs. Now you need some way to save it and serialize it, right? And that's where you have model files, depending on the framework that you're using. This is going to look different, but across the board, for the same, for generally, it's just a file, right? And what you typically do with these files is you take them and then you deploy them to some sort of deployment target, which is, again, a desktop application, an IoT device, to the web as a web service, or your mobile clients, right? And essentially deployment, that's really all it is. You take a file, you serialize your model, and then you deploy it to one of these deployment targets. Now, all of this, it can be very experimental, and machine learning is very experimental, kind of like we saw earlier, that it's a loop, that it goes back, prepare your data, train, evaluate. Which model works and choosing the right model is a little bit of an art and a science. It's like somewhere in between, right? And a lot of it is going to depend on your data, and it can sometimes be very time consuming to sit there and manually have to try all the different models and tweak the different parameters in the models that in order to get the best performing model, right? So that's where automated machine learning comes in. So automated machine learning, what it does is it allows you to automate the process of preparing your data, training, and evaluating your data, right? And what it does is it introduces some optimizations where it will try different models based on your data, and it will evaluate them and look at the performance metrics or the evaluation metrics to try to determine what's the best performing model in terms of evaluation metrics, in terms of how long it took to train, right? So you can definitely leverage, and you should leverage, automated machine learning as much as possible when you're building your machine learning models. In terms of the machine learning landscape, if we take a look externally, we have scikit-learn, which is a very popular framework. You can use it with Python, right? And scikit-learn, what you can do with it is essentially traditional machine learning models, right? So you can build traditional or classical machine learning models, so regression, classification, so on and so forth. And then you have TensorFlow, which is an open source library. It's typically used for deep learning, but you could also build classical machine learning, use classical machine learning algorithms with it. You also have PyTorch, which is or Keras, which is a higher level API that allows you to essentially use several different backends to build your deep learning models and your neural networks. And then you have PyTorch, right? So PyTorch, again, very similar. It's just this framework that allows you to build classical machine learning as well as deep learning models. And in terms of TensorFlow or PyTorch, they're both very similar in terms of the capabilities that they provide you and the types of models that you can build with them. Again, but they have different approaches as to how you can use their APIs. Okay, and in addition to that, now you have Onyx, which is external to Microsoft, but at the same time, it's also internal. This was a project that was sort of worked in collaboration, I believe, with Facebook. And what Onyx does is it's a format. It's an interoperability format or a model format, among many things. And what it allows you to do is you can take models that you build with any framework, for example, PyTorch, scikit-learn, and then you can convert it into Onyx format. And then what Onyx format allows you to do is it allows you to consume the models, right, to perform inference on the models with the framework of your choice, such as ML.NET, right? So what that means is you can build a model with PyTorch, you can convert it to Onyx, and then you can consume it from an ML.NET application, right? In addition to that, you have the runtime, right? Which that's also what allows you to make inferences with the runtime, and it gives you some boosts in performance. At the same time, recently it was announced at Build that you can also train your models now with the Onyx runtime. So now that's a new feature, a new capability that you can use with Onyx. Okay, so if we were to look internally at Microsoft, what offerings does Microsoft have? So you have cognitive services, and cognitive services, it contains pre-trained models that you can consume via REST APIs, right? Then you have Azure Machine Learning, and Azure Machine Learning, what it does is it provides this environment for you to build assets, basically instantiate resources to train models with. You can build custom machine learning models with it as well in the language of choice, whether that's Python or R. And it provides several tools that will allow you to do that, such as the VS Code Azure Machine Learning extension. You also have WinML, which is a way for you to consume models in Windows, right? So you can take Onyx models or any other type of model, and you can consume it with WinML. And then finally, you have ML.NET, right? And as Bree will explain later, kind of a little bit what ML.NET. ML.NET is an open source framework, cross-platform for .NET developers to build machine learning applications in .NET. Okay. So how can we look at all of these frameworks? There's actually many ways that you can cut across these different frameworks, but a few ways that you might want to look at it when you're trying to choose a framework or one of these offerings, right, is can you train custom machine learning models, right? If you don't necessarily care, let's say that you just want to predict sentiment and across the English language or whatever language it may be, perhaps something like Azure Cognitive Services may be something that may be more appealing to you, right? Because you don't necessarily need to you don't care about having custom words or things like that. But let's say that you wanted to train something on medical terminology or some sort of very specific terminology within your industry. So then training custom machine learning models is something that you want to do, right? So in that case, perhaps something like Azure ML or ML.NET might be something that's more appealing to you. In terms of model consumption, you have to think about how it is that you're going to, or which types of models can you consume, right? So with WinML, you can consume Onyx models. With Azure Machine Learning, you can Azure Machine Learning, Azure Cognitive Services, you typically do this via REST APIs, though you're not limited to that. And then with ML.NET, you can consume both ML.NET, TensorFlow, and Onyx models. And then also, how much effort is involved? Like, how much knowledge do I need to have beforehand? And with some of these, like Azure Cognitive Services and ML.NET, you need to have very little machine learning knowledge. With ML.NET, you have the tooling like Model Builder and the CLI, and which are built on top of automated ML or AutoML, and the amount of ML knowledge that you need to have there is fairly minimal, right? With Azure ML, you, depending on what you use, whether you're using the SDK or whether you're using the designer, the level of machine learning required varies, right, when you're building your machine learning models.
Awesome. Great recap, Louise. So before we move on to the next section, I wanted to see if there were any questions on that first section, anything about machine learning. Either I can read them over here, or Alexander or John, if there were any questions, you can let us know. And I just saw that my mic was a bit far away, so I tried to bring it closer. Hopefully it sounds a bit better.
I think it sounds great, Bree. And so far, I think we don't have any questions right now, but we're looking forward to the rest of the workshop.
So you're saying our explanation on machine learning was so good that everyone is our experts now. Perfect.
Crystal clear.
Perfect. So I think I do see one now. Can ML.NET do everything that the other frameworks can do? I guess it depends which frameworks you're talking about. And I will go through the whole ML.NET section, and if you still have that question, let me know at the end of that section, and I can clarify a bit, because you'll have to specify which frameworks you're talking about. But I will go through all of the different capabilities, features, and what you can do with ML.NET in the next section. So we will get started. So let's talk about the history of ML.NET just to start off with. So Microsoft Research in around 2002 began this text mining search and navigation research. They wanted to enable internal developers at Microsoft to easily add custom machine learning to internal products or Microsoft products and technologies. And then in 2011, the library was actually renamed to the Learning Code. It was still internal, but it was widely used and still is widely used within Microsoft. So this could be for features like Windows Hello, Bing Ads. We've got Power BI Key Influencers, which is actually ML.NET now. So a lot of different internal products actually used the TLC when it was developed. So then in 2018, that's when we made TLC open source cross-platform, released it as ML.NET. So that was the first public preview we released in the build of 2018. And then in the next year, 2019, we had our GA release. And then of course, today in 2020, we've got our first all ML.NET conference. So what is ML.NET? It's an open source and cross-platform machine learning framework for .NET. So it can actually be run anywhere the .NET can run. So it's, again, cross-platform, Windows, Linux, and Mac. You can run it on offline applications. You can run it in the cloud, such as Azure. And to be more specific, ML.NET is actually built for .NET developers. So in highlighting the .NET part, that means that .NET developers can stay in the .NET ecosystem to train custom machine learning models. They don't have to go and learn a new ML tech stack to do that. And then highlighting developers, again, data science and machine learning experience is not required to use ML.NET. The features and tooling that we have, which I'll talk about a little bit in the next slide, really enable developers without that experience to use ML.NET. Great, so I'll talk a little bit about the tooling and AutoML. So we've got on the base, we've got our ML.NET API. Again, that's cross-platform. You can use it in VS, VS Code, whichever editor you want. There's also actually support for Jupyter Notebooks. And then on top of that, we've got our AutoML.NET API. So Louise talked a little bit about automated machine learning before. So this takes advantage of automated machine learning locally so that you can easily get a trained model by just inputting in your data and choosing the scenario. And we'll go through that a little bit later as well. But on top of that, we've got our tooling. So we've got Model Builder, which is right now just in Visual Studio. And we've got the ML.NET CLI, which is cross-platform. And again, this next slide will give you a better picture. So with our tooling, Model Builder in Visual Studio and the cross-platform ML.NET CLI, you can easily build custom machine learning models, taking advantage of that automated machine learning or AutoML. With these tools, it actually generates the code for training and consumption. And then we'll wait for right in downtown Seattle, and it's fast. So with Model Builder, it's currently in Visual Studio only. It ships with VS 16.6. There was a little issue that we had with our latest release that I think somebody might have already mentioned in the chat. So there's actually a workaround for that I think they might have already posted there. So you should be able to work around that until we get that fixed in our next release, which I believe should be next week, or the next VS release. And with Model Builder, there's actually integration with Azure Machine. You can stay in Visual Studio, but still take advantage of Azure ML and the power of the cloud to scale out. And then here you can see an image, kind of an example of Model Builder. And then we've got the ML.NET CLI, which again is cross-platform, and it's a little GIF of it running and training the model, and then it's still consumption. Now I'll talk a little bit about the ML tasks that are supported with ML.NET. We've got classification. This can be things like sentiment analysis, categorizing emails as spam or not spam, classifying law documents. A really common use case I see is people have surveys and they have these free-form comments and they want to categorize it or automatically categorize it into different classes. For instance, in the medical field, and you can do it by provider, by wait time, facilities, and so on. We got regression. So this is essentially value prediction. You want to predict a number. So this can be things like price prediction, predicting the sales of products based on advertising budgets, and a lot of different other examples. You've got forecasting. So this could be things like predicting future sales based on past sales, things like predictive maintenance, or even weather forecasting. And then anomaly detection. So this could be things like identifying fraudulent transactions, learning patterns that might indicate that a network intrusion has occurred, or even checking values that are entered into a system. ranking. This could be things like search results ranking, clustering. Can be things like customer segmentation, and then recommendation. You can recommend products, movies, and so on. These are all the classical or traditional machine learning tasks supported by ML.NET. We've also got some deep learning tasks supported by ML.NET. And so that will include things like image classification and object detection. And the difference here is image classification, you'll just have one class per image. So you could say, okay, this image is a dog, this image is a cat, or this image is bread and not bread. Versus object detection, you can actually have multiple classes of one image, and it'll actually kind of draw that bounding box around it. So Luis talked a lot about the other ML tech that's offered at Microsoft. So here's how ML.NET, or some ways that ML.NET can integrate with these different products and services. We've got Azure Cognitive Services. Custom Vision is one of the features or products that they offer. So this is for custom image classification or object detection training. So what you could actually do is train, if you wanted to, image classification or object detection model with Custom Vision. And then you can export that to Onyx and then consume that Onyx model in a .NET app using ML.NET. So ML.NET does support consuming Onyx and TensorFlow models. If we're looking at Azure Machine Learning, if you actually start in Model Builder and Visual Studio, after you choose image classification, you choose Azure as your training environment, you choose your data set, and then you set up those experiments all within Visual Studio, then what it'll do, it'll train up an Azure ML using Azure AutoML, and then it'll bring that back down and download the model for you, and you can consume it in your .NET app. And you can do all this without leaving Visual Studio. And then we've got WinML. So with this, you can train, using ML.NET, train a model, export that model to Onyx, and then consume that Onyx model with WinML in Windows desktop apps. And what's nice about this is you can use the GPU for inference with WinML. Okay, so if you're trying to when should you use ML.NET, here's just a few examples. If you want to stay in the .NET ecosystem for machine learning, if you don't want to worry about the low-level complexities of machine learning, if you wanted to train a custom model versus just using a pre-trained model, but you also have the option to consume pre-trained models. Right now, we support Onyx and TensorFlow, like I mentioned before. All right, so we're done with the ML.NET portion. The quick introduction, obviously, we will dive deeper into it on the rest of the workshop, but I wanted to pause before our next challenge and see if there were any questions. So Alexander or John, anything that we can answer?
There's been quite a few questions on the chat, actually. It's been a great conversation here. I think I can start with one from Daniel. He's wondering if ML.NET is ever going to be mainstream.NET.
Mainstream.NET. Can you elaborate a little bit?
I guess I don't know exactly what Daniel meant with that, but probably like built into .NET, or I guess more widely used than what it currently is. Right.
Well, that's what we're working on, right? So as we build a community and continue to get feedback about it and grow usage, that's definitely something that we would like to do in the future. So we are committed to ML.NET, and we're really excited for some of the things that are coming up, which of course will be driven by you all that are watching and using ML.NET. So yeah, that's something that we definitely like to do.
Awesome, yeah. And Visal has a question here on, when you say ML knowledge is not required, do you mean the ML algorithms needed for different scenarios?
Right, yeah. So essentially there's two different ways that if you just use the API, you will have to choose the algorithm. And we do split up the algorithms based on the task you want to do. So if you want to do classification, if you want to do regression and so on, you can actually use IntelliSense or look at the docs and see what algorithms are offered. And each algorithm also has its own options that you can choose and tune. So there's a lot of different combinations of those things, and even the data transformations that you can do or choose. But if you don't know how to do that, you can use automated machine learning to do that for you and kind of automate that experimentation process. So you don't necessarily need that knowledge of, which algorithm should I choose for this classification task that I have.
Awesome. And Praveen has one question here. How often SOTA pre-trained models get updated? I'm not sure what SOTA stands for. SOTA?
State of the art.
Okay.
Do you want to answer that, Luis?
Yeah. Honestly, not very much. I mean, I think you've seen that with in NLP, right? With BERT, right? There's always a new one coming out. But if you were using BERT, that is one of the state of the art algorithms. So you can definitely sort of build your stack or your application around one of the state of the art algorithms, and you should be okay for quite some time, unless there's a very compelling reason for you to switch and go to the latest and greatest. But again, especially in the enterprise scenarios, you don't want to be sort of switching every 2 weeks or every month a different algorithm. You should experiment, but a lot of times choosing one, at least for a year or whatever period of time you determine that it's the right approach, you'll be okay, right? Like your application will work very well.
Perfect, thank you. I think that was all the questions. There's some excitement about object detection and some interest in object detection as well. So that's something that we probably want to hear more about later.
Yeah, definitely. We'll talk a little bit about it with deep learning and then a little bit in the roadmap, but I don't want to reveal too much yet. Awesome. So then I guess we will move on. So we actually have a challenge for you all. So hopefully you all were able to get all those prereqs. And so what our challenge is, so we want you to use the ML.NET CLI, depending if you have Visual Studio or if you prefer the CLI or aren't on Windows. And given the e-commerce data set, which is in the repo, we want you to create a model that classifies these different products into categories. So you can take a look at this data set and see what it's made up of. There should be, I think there's 4 or 5 columns. You want to predict the category. So we want to make sure in this challenge you want to train and use the model to make predictions in a .NET application. So if you go to this AKA link, phase 1-2, it should have more instructions. So when I move on to the timer, you can see what those requirements are and what you should try out. And it'll give you a few hints as well, such as training for at least 40 seconds based on the data set size, even though Model Builder might show a different number of seconds, or you can choose that in the CLI. And a few other hints of how you might get started with Model Builder as well. So once I switch to the next screen, it'll start a 3-minute timer. Louise, anything you want to add before I move on to the next slide so that everyone can start the challenge?
Yeah, I just so I pasted into the chat. If you still are trying to, or you haven't installed the prerequisites, you're going to need them for this challenge. So I pasted the link into the chat so that you can install those if you want to take part in this.
Yeah. And there's no prize for winning this challenge, but we can give you a shout out if you want. It should just be a fun thing. And we just want to show you, hopefully, how easy it is to create a machine learning model really quickly with ML.NET and the tooling. So I will now move on to the next step, and that's when this challenge will start. And we can answer questions as we go if something comes up, or just chatter for 3 minutes, or just let you all concentrate. So let's start that challenge now. Was there anything we wanted to answer while people are working, or did we want to just give them time to think? What do you all think?
I think we can let them think, and we can answer questions at the same time if you want
Cool.
to. I have 2 questions here. I'll ask the first one that's been asked twice so far. Is there PMML support? Do you know what that stands for?
I don't think I do. What is PMML?
Backslash. Would you like to elaborate on that? What PMML stands for?
I'm not good with acronyms. I recently discovered.
Predictive Model Markup Language.
Louise, do you know anything about it, or?
Louise,
I've heard of it, but I'm not too familiar with.
Okay.
Yeah, I'm not too familiar. Oh, actually, you know what? So no. So the short answer is no. But if that's something that you'd be interested in seeing, by all means, you can go to the .NET Machine Learning repository. Again, this is open source, so you can raise an issue there or suggest that this is something that you would like to see. And I'll paste into the chat the link to the repo.
Great, thank you. Samuel Brewer has a question. What's the status of exporting ML.NET models for Onyx?
Yeah, so we're constantly adding more support for that. I know only some tasks are currently supported. I think with the newest release, there were even more. And it's actually at the last slide of the roadmap. I don't have like a specific status, except that we are trying to add more and more support to that. Unless, Louise, you have anything else to add?
Yeah, no. Again, so I just pasted the link to the repo in the machine learning ML.NET repo, and you can actually follow the conversation there. You can see that there's been a few PRs that have gone in to sort of address this. So it's certainly a work in progress, and it's no easy task, but it's definitely a work in progress.
Yep. So I see here someone said, I want to work for Microsoft, but I'm still in college as a software engineering student, but I failed a class. Don't worry, there's hope. I took an artificial intelligence class and got a 52%, and yet here I am. So teaching people about AI and ML. So there definitely is hope.
There you go. Awesome. And I think a lot of people as well, especially myself here, just to give some experience, is that I started off as a chemistry major, went into software engineering, and then now doing MLNET and machine learning. So there's many paths that leads to Rome, right?
Right, exactly. All right, done. Timer is almost up. Okay, timer's up. Well, go on to the next one. Go on to the next slide. Maybe, if my computer will let me. Here we go. One was able to complete the challenge. So feel free to post that in the chat, and then I'll actually do a quick review specifically with Model Builder of what that should look like in case you didn't get there. So let me change here to Visual Studio. All right, so if you're using Model Builder, what you would have done is you could have created a new application. You right-click on your project in Solution Explorer, and my computer is lagging a bit because of all the different things that are happening. And then what you could do is you could add machine learning, and what that'll do is open up Model Builder here, and I would have selected a scenario. This is actually a different build, so it's an internal build, so it might look a little bit different, but now you just get to see what's coming up. So I would have chosen, and right now we just have the local experience for that. I chose my data set. In this case, we have we have 5 columns, including the category, the product name, the price, and the description. And you could have chose to filter out different features based on what you thought would impact the prediction the most. And then when I trained for 45 seconds, and in that 45 seconds, what it was doing was using AutoML locally to find the best model for my data. In this case, based on the amount of data I had, 45 seconds was enough to explore one model, but it gave me a pretty good accuracy, so that was good enough. So then if you go to the evaluate page, you can actually try it out in the UI itself. So what you can do is you hit predict, and this is just taking the first one from the data set, and it predicts that it's clothing. So if you tried something else like, I don't know, dog food, or my dog, we'll see. No promises, obviously depends on the data. All right, yeah, so it actually predicted that it was pet supplies. So you could try out a little different combinations, and then of course predict it on new data. And see what it would categorize it as, which gets rid of that manual process of having to go through each one and tag it. And then in the end, what it does is it'll actually add these projects here. We've got the console app, which has the training code, which I can open here. It has this training code of the pipeline that it built. And then it has sample code of how you can use this in your application. It has the actual model here. It has the class for consuming the model, so you can just call this in the input and output, which we'll talk about a little bit later. But you can see here, I'm not going to run it because it's probably going to be way too slow, but what it will do is actually print out the features that it had and then the prediction and compare that to the actual one. So yeah, so so CLI is, yeah, another great way to go. I don't have that open right now, but in this, what you would do is you would say, you download MLNet, or the MLNet tool, which is just a .NET global tool. And then you use MLNet and then the auto train command, and then you can choose your ML task, input your data set. The same steps as here, just without a UI. And it'll generate the same code for you.
Real quick question.
Yeah.
I think, could you elaborate a bit more on which machine learning task you chose? I believe you chose multi-classification, right?
Yeah, so in this case, so what we've done here is we've tried to make it more scenario focused or more, I guess, generic scenario focused. Our old design, we had very specific examples. So we had like sentiment analysis, which really would have covered all binary classification tasks. And we had like issue classification, which again was really specific. So what we've done is actually pull it all into text classification, which we've gotten the feedback that that's a bit misleading. Because text classification actually means a different thing, and I did hear that feedback, so we'll definitely fix that up. But in this case, yeah, I just chose the classification task, which will detect if it's binary or multi-class, so you don't actually have to choose between those two, and then it'll give me the right thing. So we try to include the more specific task or data science term of like regression, or I think that's actually the only one that we thought might be a bit more confusing, and we'd want to do more of a scenario focused. So yeah, it was if you're looking at the CLI, that would have been classification or multi-class classification.
Perfect, thank you.
Let's see, I'd like to see the demo with the CLI. Okay, we can give it a try. Why not? I wasn't planning on doing it, but for you all, I guess I can do that. Let's see. Assuming that my computer will let me. Let's see. All right. So here you can see that I have MLNet installed. We're actually updating these commands very soon and making it a bit more .NET CLI-like, but I'll show you this version anyways. So I'm going to CD to my desktop, and I'm going to, let's see if I can get these correct. I usually use Model Builder more than the CLI, so we'll see if I can actually get this right first time. So I would choose my ML task is multi-class, classification, and then we do our data set, which I believe is e-commerce. I just renamed it to that. And then our label column is category. And let's say, well, let's just do it at that. Of course, I missed something. Category. Okay. Like I said, I don't use the CLI that often, but what did I do now? Label column name, that's what it was. Okay. And again, we're making these simpler so that people don't have to go through this. So that'll be in the next release, which should be, I think, this next week. All right. So you can see that once I actually got the command right, I chose multi-class classification, I chose my data set, I chose my label column. I have all these options as well. I could have chosen how long I wanted to train for. In this case, it's going to train a bit too long, so I probably won't complete the whole thing. But yeah, so what would happen is it would complete the training, it would show all the algorithms that it found or the models that it found, and then it would produce that code for you that was shown in Model Builder. And we have more docs, so you're totally able to go through the docs and see how you can do this and try it out on your own, and then ask any questions that you need to hear. So you can see it actually found that algorithm, and it'll keep going until I can't remember what the default is. It might be like 10 minutes. I think we're changing that in the next one as well to something a little bit less. So hopefully that was a good enough demo of it so that we can move on in the next section. Oh, that's right. We actually have a break now. So we'll have a quick 15-minute break. Louise and I can answer a few questions, and then we'll try to take our little break, maybe go stretch our legs or something. I did include a little fun machine learning joke or tweet. Thank you, Steve Main, for this. But yeah, so we'll take a 15-minute break. Feel free to go stretch your legs, go eat, bathroom break, whatever. And we'll stay for a bit to answer questions and then take our break.
Perfect. All right. So if anyone has any questions in the chat, please put them in the chat on either Slack or on YouTube or Twitch. And we'll make sure to relay them as well. And just a reminder as well, if you want to join the Slack community, we have posted a link in the chat. We can do that again for newcomers. And that's going to be kind of where we hang out going forward.
Yeah, and also if you didn't get a chance to do the challenge, or you were still, installing the prerequisites, definitely make sure to get those done during this break. That way, you can actually build the app that we'll be going through throughout the workshop.
Exactly, yeah. And there's been some questions as well on the Slack and on YouTube and Twitch if we're going to record this, and this is being recorded, and we'll upload the workshop recording as well to the YouTube channel afterwards for those in different time zones.
They're not invisible here.
Yeah, I think I'm the only one without a green screen, so, or I could pretend it's a green screen, and this is not really my apartment, but.
So Liquid then asked a question here. In the CLI, what was the column you bound off again? I guess which was the answer label column, I guess that was the question.
Yeah, so in the data set, let's see if I can actually pull it up here and show you that. If you're having trouble downloading the CLI, make sure you have .NET Core, I think it's 2.1 installed. Right now we don't have the 3.0 tool out, but that will be out, I think next week or very, very soon. But if you wanted to try it now, you'll have to have 2.1 installed, .NET Core 2.1.
And we have another question as well here. Is the AutoML train step realized on a GPU if available, or is it only on a CPU?
Yeah, so right now we just have it on the CPU. So we'll get into it a little bit later. An image classification API, which does take advantage of the GPU. So right now it's all CPU, and we're looking into more GPU support. But currently, we don't have that.
Okay, great. Another question here is for data manipulation. Is your goal to give enough APIs in MLNET to do them there, or do you think that it should mostly be done outside of ML.NET, example SQL and so forth?
Mm-hmm. Louise, do you want to answer that one?
Yeah, absolutely. And I would say that it depends, right? It really does depend. And are there any specific transforms? I'm not sure how to pronounce that. Nsulikov. Are there any specific transforms that you're looking to do that are not there already? And while you're answering that, I'm going to say that it really does depend. And at the moment, we do have some transformations that you can do, right? You can do normalization. You can do, dropping columns. So there's a few things that you can already do with ML.NET. So if there's stuff that isn't there already that you would like to see, please raise an issue or ask for the feature in the machine learning repo. That being said, though, kind of going back to the machine learning process, right, that where I was talking about as you're getting the data and you're choosing where your data is going to live and stuff like that. These are questions that you can sort of answer by doing stuff outside of ML.NET. So not using the ML.NET API directly. Again, as you can certainly leverage it as much as possible, but sorry. So yeah, so you can definitely leverage ML.NET as much as possible, but wherever you can, right, you also have that freedom. And as long as you have your data in some sort of database table, as we're going to get to later, when we're working with the different data loaders, right, as long as you have it in some format that ML.NET can read, whether that's pre-processed or not, right, you can you can do that outside of it as well.
Okay.
Yeah.
So Saul has a question as well here. Which model should I use for the case of spelling checking or spell checking? Is it text classification or something else? I would assume, I guess you can also use a pre-trained deep learning model through Onyx, because I'm sure there's plenty of those out there as well.
Yeah, that might be your best approach. Yeah. Yeah.
Okay.
I see another question. Can you integrate ML into Xamarin Forms? If so, how? So the question is, the answer, the answer is yes. Bobby, you can, right? So one way that for sure it's going to work is and we're going to get into this in the deployment phase, but essentially you want to set up a web API, right? So host your model as a web service that you can then call from your Xamarin Forms. Can you use it directly? To be honest, I haven't tried it lately, but my understanding is with .NET Core 3.1, you should be able to use ML.NET in ARM with ARM chipsets.
Great. And question here as well. What are the advantages with GPU computing? Do you use it in it or use it in any other of your projects?
The advantage of GPU computing, that was the question?
Yes.
So it just makes things faster. So right now ML.NET, again, the image classification training with the API takes advantage of the GPU. So while if you have the CPU, it can take kind of a really long time, depending how many images you have. So if you have a lot of images, it's really nice to be able to take advantage of the performance of the GPU and be able to train a lot faster. We don't currently support inference with the GPU, although I don't know if we've gotten that request that I remember. I don't think people have had issues with that quite yet. But yeah, does that answer the question?
I think so, yes.
Cool.
Another question here is the Visual Studio for Mac support for ML the same level as Windows Visual Studio support?
Is what support?
Is the machine learning, I guess, Visual Studio for Mac support for machine learning the same level as for Windows Visual Studio?
Yeah, so you can definitely use the ML.NET API in VS for Mac. You can, have that code first approach. Right now, Model Builder is only in Visual Studio. If you want to see it in VS for Mac, definitely put it in our repo, request it in our repo, and we can take a look at that. There hasn't been super high demand for that quite yet, but it's definitely something we can look into. We actually had a community member create a model builder for VS Code, which was really, really interesting. I'll have to find that. And I think I shared it on Twitter. I can't remember, but yeah, that was really, really cool to see. So definitely it's something that we can look to do in the future. If you're on a Mac right now, I'd recommend using the CLI because that's our cross-platform offering.
Cool. We have a very in-depth question here. I think that's it's going to take a long time to answer, I think, but I'm going to pose it anyway because we're live. If you want to combine text, image, sound into a CNN, how will we do that?
Text, image, sound. Louise, I'll let you take this one.
So with CNNs, typically they're very good for image data, right? So you're certainly right. Alexander actually has a project where what he did was he basically took an audio file and he turned it into a spectrogram, and the spectrogram is just an image, right? And then you can just train a CNN or a deep neural network using the image classification API, which we'll talk about later, to essentially make predictions on these spectrograms, right? I'm actually working on my stream on this other thing called Stamina, which was a technique for malware classification that was created or published by Microsoft and Intel. And what that does is it takes binaries, converts them, like let's say a text file, you get the bytes of that file, convert it into an image, and then train a deep learning model to essentially make predictions, classifications on whether a file is malware. So the short answer to that is, as long as you can take something and turn it into an image, any file and turn it into an image and feed it to some sort of deep neural network, it's possible. Yeah. So that's an approach that you might want to take.
And I think I'm just going to add as well, there's something called multi-headed neural network as well, that I'm not sure, I'm not an expert in that, but I think that may be something as well to look into, but that's definitely outside of the scope of MLNET, I think, right now.
It can be, but and you can certainly stack models. It's something beyond the scope of what this workshop is going to show, but you can do model composition. So essentially you can have multiple models on top of sort of each other, and basically one model, the prediction from one of the models could then be used as input or features for another model. So it's certainly possible, but again, beyond the scope of this workshop.
Awesome. I can take, I guess, one more question if you want to break after that. We have Matthew here asking, why does the model input class contain the predicted label as an input?
Yeah, so if you remember when we talked about machine learning before, we said that we give it the data and the answers. So in order to learn from the data and create a model, we have to have that historical data that actually has the answers already in it, so that we know, if we're talking about classification, we know that this comment is positive or negative sentiment, or this comment is positive or negative, or this is in this category. So you actually have to have those labels as the input. and then the output would be the prediction of new data. So it has to learn from that input. Does that answer that question?
Most likely, yes. Okay. Well, if you want to take a short few minutes break there as well, I know it's going to be a long day for you both. I guess feel free to do so right now.
Cool.
And for those still here, I'm going to stick around. I'll show myself as well. Me and Luis are still here right now, live and viewing.
Yeah, I'm actually gonna refill the water cup.
Go
So
for it,
I'll be right
Luis.
back.
No worries, Luis. Go for it. I'll be here by myself. Awesome. So if you have any questions in the meantime, put them in the chat, and we'll try to answer them as we go along. And again, feel free to join the Slack channel for those who haven't joined it yet. That'd be great. And we got John here as well, answering any questions you have.
Yep. One thing I want to highlight here, I know Bree mentioned PRs within the ML.NET repo. It is open source, so definitely feel free to look through the issues, see if there's anything you want to take, help the team. The team is the team's awesome. They'll definitely help you out if you ask.
Absolutely, and I also encourage people to contribute honestly to the repo. It was very daunting for me in the beginning to start thinking about how to actually code things to the repo. But there are some really good up for grabs issues, and MLNET team is very, very helpful in pointing you in the right direction. And I know you, John, are very active as well, answering questions and pointing people in the right direction, both on Stack Overflow as well as on the GitHub repo. So if you see something you want, I would encourage you all to help out as well, which is awesome.
Yeah, the up for grabs label and the documentation label is also a good one to look at.
Yep, exactly, Rutix. I see you're answering a question in the chat here. Yep, it's up for grabs. There's also good first issues. There's not too many of them. There may be 5 or 10 of them. But I encourage you to start looking at them. Another really good place to start looking as well is documentation issues. So those are usually pretty simple to fix and kind of gets you into the process of doing this. I actually had a stream myself a few weeks ago where I contributed to a repo and showed how you kind of pull down the source code, how you start building all the binaries underneath the surface and run tests and so forth. So definitely kind of tune into that if you are curious about how to get started there, which should be good. And Bree is showing off her dog here. What's the name there again, Bree?
This is Malibu. She just jumped up and hit a bunch of keys, so hopefully she didn't. I'll show her off. Why not?
Awesome.
This is Malibu.
So how tall is Malibu again?
Well, see if we can. She's about my height, which would be about 5'2".
It's a very tall dog. Awesome. Great. Well, we just me and John were just talking about how to contribute to the repo here during the break, and hoping to get more people doing so because I think it's so beneficial as well. And I think as also from my experience and from John's experience as well, it's great working with you, Bree and Luis. You're very responsive to feedback. So if anyone has feedback to the repo, I encourage you to open issues on the repo or reach out directly.
Is that our co-presenter?
It is, yes. I'm going to get her an I Love ML.NET shirt also.
She'll be going over the deep learning section.
Yes, true. All right, I'm going to switch back to you guys if you want to continue.
Awesome. Let me come back here. Give me a second. There's a little bit of a delay on my computer. Okay, there we go. All right, so we'll start with phase 2 now. This is where we'll start digging into the app and actually starting to build something. I promise we'll give you more than 3 minutes this time. So this is kind of the outline of the problem that we're going to solve and a little bit of the app details. Again, you can go to this AKA link to, this is, I think we gave this before, but this is just the actual workshop here, and the workshop repo, and it'll be in there. So what we're going to do is create a web app that lets users input in data about their car. So this could be a year, make, model, mileage, and it'll return how much their used car is worth. So this is going to be a regression task because we're predicting a value or that price amount. And the details, so we're actually going to train this regression model in a .NET Core Console app with the given data set, and then we're going to consume that model in an ASP.NET Core Razor Pages web app. And again, we'll teach you a little bit about each step first, and then we'll give you some time to work on that and ask questions. So looking at ML.NET, most scenarios will require the Microsoft.ml NuGet package and just that NuGet package. So you'll have to reference that, install and reference that. Some of the other tasks, this is going to look a little overwhelming, but it's not too bad. Some of the other tasks require other or additional packages as well, and you can see a list of those here. And again, that we'll be sending out the deck after, so you don't, so you'll have all these in case you want to try out any of these scenarios. So getting into the framework components of ML.NET, we've got our ML context. So this is the starting point for all ML.NET operations. It gives ways to create components for data prep, training, prediction, model evaluation. So everything's going to start with the ML context. It's essentially an environment for ML.NET. So you can see with IntelliSense, it picks up all the different tasks that you have here or the data. And then from there, you can see all the different actions that you can do with that. And I believe a lot of people compare it to DB context and NV framework. I don't know if it's an exact direct comparison, but that's what I've heard it compared to a lot. So that's really it for this phase, is the NuGet package and the in the ML context. So that'll be your first task. So make sure you have that repo cloned if you haven't already. There's the link again. So in your console project, I think it's called Train Console, what you're going to do is add the Microsoft.ml NuGet package, and you're going to initialize a new ML context. If you go to this AKA link, phase 2.0, that's actually going to have the instructions and the code for you so that you can follow along and learn a bit more about each thing, or if you need a recap. So yeah, so go ahead and complete this part of it. And if you have questions, we'll be here. Malibu's also open for questions, so but yeah, go on ahead.
So question is, do we add it to the shared project? And yes, you add the Microsoft ML NuGet package to the shared project.
And we're also using the latest version, right? 1.5 that was released this week, right?
Yeah, we got that in. Making the switch was actually really easy, because we started this session with 1.4 and then 1.5 release, and I was like, should I do it? Should I flip the switch on 1.5? But actually, it was literally just update the NuGet package and everything worked. So yeah, it's great that there were no breaking changes.
That's what the release note said, and I'm glad that was the case as well. So maybe I'm stealing some thunder here, but I'm going to ask my own question here. Louise or Bree, what is the ML context and what does it do here, since we are creating one of those here?
Yeah, I talked about it a little bit. Louise, do you want to talk a little bit more about it?
Yeah, it's a way for you to collect. It's a way for you to kind of collect a lot of the operations and control a lot of the operations that are going on with the model. And Bree mentioned it, like, you know, if you want to do data prep, if you want to do logging, you can use the ML context to sort of tap into the state of basically the entire training run or the entire operations, all the operations that are taking place throughout a model building process, right? So that's essentially what it is. It's just this component that internalizes state as the different operations are performed on a data set or as you're training a model. Yeah, and it it initialized it. It's the entry point to an ML.NET application. Yeah, and it's just a way for you to control what's going on throughout. Most of the time, you're not going to like access it directly in terms of the logging and the execution control, but it's there if you want to.
Are there any other questions, Alexander?
I think right now it looks good, I think, with questions here.
I see Steve joined our workshop. Steve Smith.
Hey, Steve.
Yeah, he helped us immensely with this workshop as well.
And I believe Steve also streams on Twitch as well regularly, right? So for those who don't follow him, you should definitely check him out. Awesome stuff.
Absolutely.
Someone has a question. Anxiously awaiting.
Yeah. So Hyping has a question here at least. Actually, let's start with TH1Can here. Does the AutoML feature use only accuracy to select the most appropriate model, or it benefits from other metrics like precision, recall, and F1 score?
Yeah, that's a great question. So in Model Builder right now, it's limited to just what we consider the most commonly used metric. But if you're actually using the API, and I can't, Louise, do you remember if in the CLI you can choose which metric it uses?
I don't remember the new version of it, but in the tooling, I think it does default to accuracy. But if you were to use the API, which again, that's kind of what the tooling uses, you do have the option to optimize which metric you want. You're able to choose which metric you want to optimize.
Yeah, and if you want to see that in the tooling, definitely file an issue on our GitHub repo, and that's something we can look into. We've heard requests for other more advanced features, I guess you could call them. So that is in our roadmap. So if that's one of the ones you would want to see, which would definitely make sense, definitely let us know.
Perfect. So going back to Hyping's question here, does ML.NET have a plan to expose low-level APIs to model developers or data scientists?
I mean, I guess it depends how low level do you want to get. Like, right now, I don't think there's any plans for that, or at least changing up the API too much. But again, if that's something that you would want to see, if there's something missing from the current API, let us know and file an issue. Louise, do you have anything else to say about that?
Yeah, no, I think Tensor. So, yeah, that's a good question. I would raise it on the repo, right? The .NET Machine Learning repo for tensors. There is tensors. You can create tensors with C#, right? So that's a capability, and I believe Hyping, you are doing that with TensorFlow, right? With TensorFlow.net. But if you would like to do it with ML.NET, I don't think that's something that's. I don't know if that's something that's available, or at least not publicly exposed, right? So maybe that's something that you might want to raise in the .NET Machine Learning repo. And actually, I noticed here, sorry, a little bit off track, not related to that question. I noticed that on the slide it says add the Microsoft NuGet package to your console project. It's actually to the shared library, not the training console. It's to the shared class library. So just clarify that a little bit.
Sorry about that,
y'all.
Yeah.
Yeah.
Going back to TensorFlow.net, so we're going to talk about it later, but our image classification API, we call it a simplified API because you just have to say you want to do image classification and give it your data and the classes and such, but that's actually built on top of TensorFlow.net. So that would be the low level way to do it. And I think I don't know if I have the image in the deck, but it's like 300 lines of code for TensorFlow.net versus the 3 lines of code for ML.NET because we wanted to simplify it. But if you wanted to dig deeper, TF.NET is definitely something you might want to check out. And if you want that exposed in ML.NET, again, let us know. Or, open source, so feel free to start working on it.
So how are everyone doing here on the chat? How's the challenge going? Done, Rudy says. Okay. I think people are getting done here.
Cool. All right, so we'll go ahead and move on. I believe at the bottom, and correct me if I'm wrong, Louise, at the bottom of each phase, there is a way to see where we're at right now, or where you should be, essentially. Is that right, Louise?
Kind of, yeah. So when we move to the next phase, starting with phase 2.1, you're going to be able to access the code. For example, if you got lost somewhere along the way, you're going to be able to download the code that you should have had from the previous section. So starting with phase 2.1, you're going to be able to see where you should be in terms of the code.
Yeah, and we'll also review it. We'll show it to you, show you the actual code of where you should be at that point at the end of each phase. This one we didn't do because it was just adding the NuGet package in that one line of code, but these will show up when we show you that next phase. So. Cool. So we're going to talk about data, and Louise, I believe this is you.
Yep. Let's get to it. All right. So as we mentioned, data, that's the most important part. If you don't have data, you can't really train a model. All right. So in terms of data, how is it that ML.NET represents, or how does it represent data? And the way that it does that is with an iData view. Now, an iData view, you can think of it of a way to represent data, tabular data in rows and columns, right? And one of the nice things, or why would you want to choose, or why an iData view? One of the things is that it's high dimensional, right? So you're able to, one of the things that you're able to do with ML.NET is you're able to represent data, especially data that has similar data types as vectors, right? So you're able to vectorize your data, create feature vectors, which again, that helps with computations and again, helps with processing high dimensional data sets. The other thing why you might want an iData view is that it's lazy and it's memory efficient, right? So as you're going to see at the end in the task that we have planned for you, although you're going to load, or at least you're going to set up the code to load the data into your application, you're really not actually loading the data. So the data is not accessed until a certain step within a training pipeline or a training process. And again, what that allows you to do is you're able to basically process large, high dimensional data sets, right? And the other nice thing is that iData views are immutable, right? So they're immutable, and as a result, when you perform transformations on your data, you're able to essentially replicate what has happened, and you're not changing the original data set. You're just creating new versions of the data, and you're essentially applying transformations to that. But again, you're still able to access your original data set without mutating the actual data. And one of the nice things about the iData view as well is that it's interoperable, right? It's in a lot of ways, the iData view is very much like an IEnumerable. And when we talk about the data loaders later, you're going to see that that's one of the ways that you can actually interoperate with iData views and represent data that's in IEnumerables as an iData view. The other thing that we'll see in some sessions, it's beyond the scope of this workshop, is working with data frames and the data frame API. And I believe that there are some sessions tomorrow that are going to talk a little bit about that. So yeah, that's kind of like a basic overview of the iData view. Now, in terms of the iData view, how exactly is the data represented, or how do you define data in an iData view? And the way that you do that is with a data view schema, which, as the name suggests, it's the schema of your iData view. And this data view schema, or the schema of the iData view, is essentially the names of the columns, their types, and any other annotations that are associated with the columns in that particular data set. Now, before you load your data, you have to define your data view schema. That way, your iData view knows how the data should look and what the columns look like, and it can do some sort of validation on that data as well as the data is being loaded. And one of the ways that you define this is using class definitions. So your standard, POCO, plain old CLR objects, right? You can just use that to define your iData view schema. So if we take, for example, a data set here, you have your flower type, sepal length, width, petal length, and petal width, right? You can turn that into a class, right? In this case, it's called iris data. And you'll notice that here we have the sepal length and width, the petal length and width, but the first column, which was our flower type, is now called label. So we've changed the property name to label, but how can we make that mapping between the flower type and the label? Well, in the data loaders, we can use this attribute called load column, and what we do there is provide a zero-based index telling it where in the file which column should be loaded as part of this. So that's how we're able to make the mapping between flower type, which is the first column in our data set, to the label property, right? And then how this is represented in an iData view, we can see that now because we've called that property label is just now becomes that column that defines the flower type in the iData view, and then the rest sort of stay the same, right? So that's essentially the data schema. Now, once you've defined your schema in terms of how your data should look like, there's different ways that you can load your data. So one way that you can load your data is using a file loader or a text loader. And what this does is it allows you to load data from files. Now, what type of files? It really depends. It can be a text file. It can be image files, right, that you load into an iData view. You have the option to load either a single file, or let's say that your data is distributed. So for example, let's say that, typically when you are working with applications kind of like Spark, right, where when you process your data and you produce outputs, all of the outputs are essentially all of the outputs, because they're processed by partitions. Your data isn't in a single file, it's in a directory that contains all of the partitions of the processed data. So what the file loaders allow you to do is it allows you to point to a directory and load essentially all of the files in that data set as if it was one. For iData view purposes, it looks like if it was one file, but in essence you are actually loading from multiple files. And the way that you would do that, if you were looking at the code, right, you can essentially just use the load from text file method. And again, you see that there's the model input, and that model input is, which we'll actually get to later in this phase, the model input is just that schema, right? You're telling it load from a text file that has this schema, and you can provide the delimiter, whether it has a header or not, and any other different options that will help you load the file, right? Now, the next thing that you can do is your data doesn't live in files, right? It can live in databases, and many times that's probably where it's going to live. And to help with that, you have the database loader. And to do that, you just, again, same thing. You create a database loader. You provide the schema of the data that you're going to be loading in from your database, and then you just call load, and it loads data from a database. The databases supported are SQL Server, Azure SQL, DB2. So there's a wide range of support for different databases. And then let's say that your data doesn't fit nicely into any of these, either database or file. Well, in that case, that's okay. What you can do is you can any data that you can represent in an IEnumerable, such as, let's say you're making calls to a REST API, you can essentially, as long as you can represent that data as an IEnumerable, you can basically bring in data from any other source. And the way that you would do that is with the load from enumerable method. And again, you're still providing that schema, so it knows how you would essentially load the data. I see that there's a question on would you load images with the load from binary. So load from binary, that one actually, it's a method that allows you to load data in what's called an ML.NET binary format. And what the binary format looks like is essentially the same text file that you have for your data. So like very similar to a CSV, but the difference is at the top, there is annotations that define the schema for you. So load from binary is not necessarily binary in the sense that it's like actual binary, like you would think of it traditionally. It's the binary file format that ML.NET has. So, yep. All right. So let's move on to Are we up to the task? All right. So in terms of the task, let's go ahead and first start by creating our schema, right, in a class called model input. Based on the card listing data set that we provided in the repository. And then what we're going to do is we're going to define our logic for loading the data from this file into an iData view. And you can get the instructions at the aka.ms link listed at the top of the slide.
Cool. Yeah, so we'll give you all some time to complete this task and answer questions as we go.
I see one question in the chat as well here. So if you would want to stream, would we be using load from enumerable with async enumerables if you want to stream data to a model?
You can, yes. That is an option. I actually haven't used. I know that async enumerables is a fairly new feature that you've that's there. So I actually haven't tried it, but I suppose that yes, because you can use enumerables and async enumerable is just an extension of the enumerable, it should work. The only caveat that I will say is that you just want to make sure that it's thread safe, right? When you're using enumerables, you want to make sure that that enumerable that you're loading data from is thread safe.
We had another question here from Praveen. Is there a plan to bring support for Azure Cosmos DB?
Bree, do you want to take that one? Plans for Azure Cosmos DB?
That is a good question. Let me think. I don't know if it's currently in the roadmap, but definitely seems like something that would be really useful. So again, any of these features that you have, let us know through our repo, and then other people also, if you upvote it, will know kind of how many, or if it would be really useful for everyone, and then we can kind of prioritize that way. So yeah, it's something that we can add. I don't think it's currently in our roadmap, but again, our roadmap is very open based on all of your feedback, so that can be something that we add for sure.
So Sam, I see a question in the chat from you where the link file is. Would you like to elaborate a bit on what you're looking for?
And I see another question about integrating with Azure CI/CD. So we're going to talk a little bit about MLOps later. We have a section on it. And if there's any questions after that you have, let us know if we don't cover anything that you wanted to specifically hear about.
And there's one question here. Is there going to be support on sentence labeling, like seek-to-seek prediction? You said currently there's no MLNET samples for that.
Could you repeat the question?
Is there going to be support for sentence labeling, like using the seek-to-seek prediction model, going beyond classification?
There
can be. Louise,
yeah.
like
Right now it's a little bit difficult, right? Because when you're using these transformer models, right? Like one of the things is that you need to also have the tokenizers, right? Which the tokenizers are in a model in themselves, though. So to be able to break that logic for tokenization, not sure if it might make sense to rewrite everything in C# or .NET, right? That being said, though, you could, for example, like there's pre-trained models for these transformer type of models. The models themselves are as they're saved as either a TensorFlow or a Nonix file. So what you could do is, for example, you might have like a combination of data transformations. Kind of going back to the earlier question, is like, should I do all my transformations inside of ML.NET or outside of it? It depends. And in this case, right, you might perhaps use Python or whichever language the transformers the tokenizers are written in, you might use it to pre-process your data, save that somewhere, and then you might use inference. You might use the model to inference using ML.NET and load in the transformed data, the tokenized data that you've saved from that previous step of pre-processing. So that might be an approach that you might take. But certainly, if please go ahead and add an issue to the .NET machine learning repo if this is something that you really would like to see.
Awesome. We have more questions in the chat here. Let's see which one should start with here. Are there any guides to use this a bit later in the pipeline, like using the new .NET data frame or DDL for exploration and data wrangling, and then by consuming those data for ML tasks? I assume one could always use the function to load enumerables. Is that the suggested method? So I guess the question here is, for data exploration, should we use enumerables, or is there a better way of doing that with a data frame maybe?
Sorry, could you repeat the question? Let me just catch up here.
No worries. I think the question is, and please correct me if I'm wrong. Yeah. Is if the suggested method to work with data explorations is enumerables, or if it's data frame or something else like DDL?
Yeah. So DDL is a really nice library, and the data frame. DDL definitely takes some time to wrap your head around it. The data frame, I think, is trying to simplify that, but again, it's still in its very early stages. So short answer is yes. You probably might want to do your data exploration and your data exploration there, right? You can use XPlot for your data visualizations. And then once you have a data set that you think is good enough to train a model, then you would go ahead and just use that and load that into an iData view. And again, there's that interoperability where I believe that you can just pass wherever an iData view is expected, you should be able to pass in a data frame, right, or an object that's represented using the data frame API.
Awesome. And then there's another question as well here about what does the output to train model look like? I think it's a zip file, however, I'm unable to visualize the contents of it. So I guess the question is, what is in the zip file?
Yeah, so you're able to unzip it, and you're able to see what's there. It's not very legible. Like you could, you could kind of make sense of what's going on. It basically has the transformations that are saved, kind of the information about the data sets, but it's just like any serialization format, right? Like it's in a format that ML.NET is able to read, right? And to your eye, it may not make sense, right? You can kind of reason about it, as opposed to like, complete binary. So you could unzip it and you can look at what's inside, but it's not going to be very useful.
Yeah.
Great. I think people are getting ready with phase 2.1 here.
Okay. Sure. I can move on then. All right. So let's do a bit of review to make sure that you all got it. So this is, I'm just going to show it in GitHub. Let me zoom in a bit. So this is going to be that train console program.cs, and I've added a reference to the Microsoft.ml package, and I've defined my file path here. And then here I initialize that ML context, and then just a little console write line to show that I'm loading the data and gotten to this point. And then you can see here, I'm creating a new iData view called training data, and then taking that ML context, using that data catalog, and then using this load from text file method. And I've defined this model input so there's my schema right here, where I have the first column name is going to be the label or that price, which is what the thing that we want to predict based on these features. So I'm loading column 1, which is a year, 2 is mileage, We're skipping a few columns because we don't believe that those will really contribute to the prediction or to the model performance. We don't think that those features are really important for our prediction. So yours may look a little different than this, but this is what we chose as the most important features. And then we chose make and model. And of course, choosing these, so it's 0 index base. So yeah, so using this data schema, then we choose our path, which we've defined above. We indicate that it has a header and that the separator character is a comma. This could be things like a semicolon or a tab. There's a few different ways, but in this case, it's a comma. So yeah, so this is, it should look similar to this. Are there any questions on this? Did anybody not get to this point, or did they maybe solve it in a different way? I don't see anything, so looks like we can move on. So now we'll talk about training, and Louise, I believe this is also you.
Hey, yeah. Okay, yeah, I can do this one. Let's see. All right. So what does training involve? So the first part of training deals with preparing your data, right? So what does this mean? It means, number one, filtering your data. You're not necessarily going to need all of the data, or perhaps to build your model, you only need a subset of your data, right? So that's kind of where filtering comes in. The other thing that you might want to do is may want to split your data into training and test sets, right? And the reason for this is you want your model to be able to generalize well. and what that means is, and we'll kind of talk about it later, this notion of overfitting. But essentially, you don't want your model to be able to memorize the answers, right? So for example, if you feed all your data, and a really good analogy of this is like, let's say you're taking a test, and when you're taking the test, you memorize all of the answers. Like, you don't necessarily learn, the concepts that you're being tested on. You just learn all of the answers to the test, and then you go take the test and you get, the highest score because you learned all the answers, right? You don't want your model to do that. You want your model to actually learn, right? And learn what the relationships between your data are. And by splitting the data, what that allows you to do is a subset of the data that the model has never seen, you train on your training set, and then you evaluate on your test set or your validation sets to make sure that it's performing well, right? So the next part is feature engineering, right? So feature engineering, that involves basically taking your features and seeing if, for example, if there are interactions between your features, trying to see how you could leverage more information out of them, right? So that, and performing transformations on your data such that your model can make sense of it. So machine learning models, they work on numerical data. So in the example that I was giving before, where you wanted to know, whether a student passed the test or not, and you were using things like what was their letter grade beforehand, the previous grade that they received, as well as the number of hours studies. There you have different data types. So part of the feature engineering process is converting the data types and making sure that they are part of that they can actually be processed in a numerical format that the algorithm can take advantage of. And then the other thing is you want to be able to normalize your data. And what normalizing your data means is you want to get everything on the same scale, right? So for example, you have a data set that one of the columns or one of the features may be age, right? And age, you think that it probably goes from 0 to 100, and maybe if you're lucky, you go past 100. But it's a very finite range, right? And then you have salary, right? So with salary, again, same thing. It can go from 0, maybe negative, but it can go from like 0 all the way through some amount, right? Whatever amount. And the scales are different, right? From 0 to 100 to 0 to several million, billion, whatever, right? They're two different scales. So what's going to happen is when you try to train your data on data that's not normalized, there's going to be a higher importance paid or a higher importance is going to be assigned, or more weight is going to be put behind the salary column in this example, right? Because it's a bigger number. So the model's going to be like, okay, that's a bigger number, therefore it's more important, right? So what normalizing your data is, it allows to basically get everything into the same scale between, depending on which normalization technique you use, to get something between 0 and 1. And then everything is sort of on the same scale, and there's no more importance placed on specific features. So how exactly do you train data, or what are some important concepts that you should know about when it comes to ML.NET? So I'm going to try my best at explaining these two, because they sometimes can be a little bit confusing. So the way that you define the data transforms and the algorithms in ML.NET is this component called an iEstimator, okay? And an iEstimator, what it is essentially the blueprint. You define the parameters of the transformation that you're trying to create. You define the transformation that you're trying to create. And then once you sort of define them and you apply them to your data, then you train your model, you train an iEstimator, then you get an iTransformer. And an iTransformer, you can think of it like the house, right? So your iEstimator is the blueprint of what steps or what transformations are going to take place. The transformer is actually the stuff that does the work, or the physical representation of what these transformations mean, right? So that's kind of the difference between these two. You define as part of your pipeline, you create a pipeline in an iEstimator, and then when you train your estimators, you get a iTransformer, okay? So, okay, let's go on to the next piece. So in terms of data transforms, there are several that you can do, right? So kind of going back to one of the earlier questions is, what can you do, or should you do these inside of ML.NET? Some of the things that you can do is, you can do, again, that normalization, depending on what you use, whether you want to use binning, min-max normalization. You do those in ML.NET. You can replace missing values, or you can basically fill in, right, or impute missing values in data sets. You can map columns, so you can drop columns, you can copy columns, you can concatenate columns. And what concatenate does is it turns a set of columns into a feature vector, or a vector, right? You also have type conversion, so you can hash your values, you can map your values to key types, and you also have a few text transforms. Probably one of the easiest ones to work with is the featureized text transform. And the featureized text transform, what it will do is it will apply a series of transforms that are typical to text processing and text transformation, such as producing n-grams, tokenizing your data, right? So featureized text is kind of like the catch-all, but even if you didn't want to use featureized text, you can use the individual transforms as you see fit, right? So these are some of the transforms that you can use. Now, in terms of the algorithms and the trainers, one way to think about a trainer is it involves the algorithm and the task. So for example, if the algorithm is stochastic dual coordinate ascent, right, that's the algorithm that's used. Now the task, it may depend on how you use it. So one, you can use it for binary classification, and the trainer that you might use is the SDCA non-calibrated binary trainer. Very similarly, if you're using multi-class classification, that would be the trainer that you would use. And then for regression, again, very same thing. You're using the same algorithm. It's just that you're applying it in a different task, right? So pipelines. What exactly is a pipeline? So a pipeline is, as I mentioned, you have iEstimators, and you can actually stack the iEstimators or series of transforms such that you're able to create this unidirectional sort of flow where your data comes in and you apply a series of transforms on your data, and basically in the end what you get is a model. And an iEstimator chain, all it is a collection of data transforms and algorithms. So in this example here, you have your iEstimator chain, which it takes in an iData view. And some of the transformations that it performs are dropping columns, you normalize your data, you use something like the naive Bayes algorithm, right? As part of your estimator chain. So you have your data transforms, you have your trainer, and then once all your data is processed, you get an iTransformer or a model out of that, right? So that's essentially when we refer to training pipelines, this is what we mean. Now, if you recall earlier, I mentioned that iData views are lazy. So up to this point, you've defined, like we did in the previous phase, we defined how can you load the data, right? You define whether it has a separator, what the delimiter is, what the file that it's going to be loading from is. You define your training pipeline, which is an estimator chain, right? Or a series of estimators combined together with the algorithm that's going to be used to train. But again, at this point, nothing has happened, right? It's not until you use the fit method, or you call the fit method, that training actually takes place. And in this case, for example, let's say that we have training data, right? We take our pipeline that we built, our estimator chain, we call fit on it, and what we get back from that is the model, right? Or the iTransformer. Okay, so again, nothing takes place until you call fit. So with all that in mind, let's move on to phase 2.2. Now, in this phase, you're going to be, one, splitting your data into train and test sets. You're going to be adding data transformations or iEstimators to your pipeline, right? You're going to be adding a trainer or choosing the algorithm that's going to train your model, and you're going to train the model. So if you go to the aka.ms link that's listed up here, you're going to be able to find the instructions for this task.
Fantastic. And we have some questions in the chat while that's being done, I guess. So Praveen asked here, is there a specific reason to use float only for load column and not other data types such as an integer?
For which column that is? Sorry.
The load column. So I guess the question is, for the numeric values, we are using float a lot in the library. Is there a specific reason for them being floats?
Yeah, so it actually, that's a good question, but typically the way that features or the values inside of features, the way that they're represented is as singles, right? So the single data type, which essentially maps to a float. Is there a particular reason? Typically, you're going to be working with floating point values. The algorithms typically work on floating point values, and that's the reason why you would prefer to use floats for that.
Okay, perfect. OSI asks, is it possible to scale geographic features as well as only numeric? Not sure what the implications on geographic features, but maybe you know that, Luis.
Yeah, I'm not quite sure what the question.
Okay. OSI, if you want to elaborate further on that question, we can ask that again a bit later as well.
OSI also had a question earlier. Is it possible to have some properties of the data set? It's possible to have them have more weight when training for the model?
I don't think that you can assign a weight to the classes. Sorry, to the properties or the columns. That being said, though, that could be part of your feature engineering phase, right? So, for example, let's say that you have a column, and let's say that you have weight. Oh, sorry. Let's say that you have I don't know, age or salary, whatever, right? So one of the things that you might want to do as part of feature engineering, right, is you might want to say multiply by 2. So so after you've like sort of maybe normalized the data, maybe you might want to multiply it by 2, or whatever factor it is that you want to give, right? Or whatever extra weight you might want to give to those features. So that might be something that's part of your feature engineering process that you might want to do. So I don't think that there's a way directly to say, hey, give this column more weight, but you can do that as part of your feature engineering process.
And for those unaware about how to use weights and why you would use weights, could you elaborate a bit more, Luis, on why you would like to use weights, I guess? You have a good example of that.
Sorry, is that a question for us?
Yes, it's a question for you.
Yeah, so why might you want to? So that would be in the case where you know for a fact, or you have a strong reason to believe that a particular feature may may have a high impact on, or you want to make sure that a particular feature has a high impact on what the model learns, right? So, um, like a specific example, off the top of my head, I couldn't come up with one, but that would be the reason why you might want to use it, because you either know or you want to have a particular feature have more importance than the others, and you want the model to learn that this particular feature has more importance over all the other features, as part of the training process.
I think a good example might be the taxi fare prediction, where distance traveled is probably going to have the most weight, or the most, that feature is going to be the most important for determining the price of the taxi fare, but number of people or number of passengers could also affect it, but maybe not as much as the distance traveled. Does that make sense? As an example.
It does for me, yeah. I hope it does also for the audience here. Thank you for explaining that. The chat, or anything you're struggling with, definitely post that in the chat, and we'll try to assist in the best way we can here.
I think I see one that we might have missed. Is there a feature for federated learning or differential privacy extensions to ML.NET platform? That I don't know much about, actually. Did you have something to say, Louise?
So, built-in, no. So the short answer to that is no. That being said, though, you could, like, there's a way, right? Because with for example, with federated learning, all that it's doing is you have some sort of centralized server with the model, right, if you will. And what you do is you then use data, or you ship the model down to the devices, mobile devices, PCs, whatever it is that you're training on, right? So you have a local version of the model on the individual's devices. You have a global version of the model in some server, right? You train locally, you get the parameter, you train locally on the user's devices, and then you basically upload the results, or the weights, the coefficients of what your model has learned, and the parameters up to the centralized server, where you're able to retrain, aggregate, and retrain, right? You could do that with ML.NET to a certain extent, right? Because you do have the ability for certain models to retrain them for ML.NET, right? So you can take model parameters, again, in this case, the ones that you receive from your devices, you can bring them into your centralized server, and then you can aggregate them and retrain the model, the global model, right, based on that. So it's not built in, but you could do it, the federated learning piece of it. Differential privacy, that one is a little bit trickier. It's a little bit trickier because there's nothing built in. Recently, it was announced for Azure Machine Learning that you could do differential privacy with this package called white noise, right? And and that could be interesting, because at the moment there's only Python bindings for it, right? So the system itself is built on Rust, and there's nothing keeping somebody from writing bindings, C# or .NET bindings, on top of Rust to bring the differential privacy capabilities to .NET, right? Is that something that's in the roadmap at the moment? I don't think so, but it certainly is something to look out for. And again, in terms of differential privacy, right? All that's doing is it's adding noise, right? So you could have like a very rudimentary way of doing that. Obviously, it wouldn't be sort of the state of the art techniques that are being done right now. But you certainly could just add noise, right? Because essentially all that's doing is somebody's making a query, you add noise to the data, you make sure that there's some sort of budget there, there's some sort of rate limiting, right? That way whoever's requesting the data can't reconstruct the original data, right? And then all those systems you could sort of implement yourself, Again, that being said, it may not be state of the art. It's not built into ML.NET, but it's something that you could do, right?
All right. So how are everyone doing on chats? Are we succeeding here?
Looks like someone, Rutix, will be giving us some feedback about the workshop. Thank you. We really appreciate that because we definitely want to iterate on this and make this a really great ML.NET workshop. I guess the ML.NET workshop that other people can use as well for teaching. We'll actually be presenting it again at a few other conferences. So any feedback you all have, definitely give it to us after. Good and bad is always great. I mean, constructive. And we'll also be sending out a survey, I believe, at the end of the conference to get your feedback about all of it. So it's like a lot of people are done with training. So Louise, you want me to move on to the next step?
Yeah, let's do it.
All right, so let's do that review and show you what we have and see if it looks like what you all have. All right, so here you can see that we've used this train data.train test split on the training data, created this test fraction, so it'll be 80% training, 20% testing data. This is one way to do it with the API. You can also have done it manually. For instance, if you had an Excel sheet and just wanted to have two different CSVs, that's another way, and you can just load them into two separate iData views. So we've got our split, and then we set up our pipeline where we, again, to start with that ML context, look at the data transforms we have. In this case, we want a categorical one, which is one-hot encoding for this make. And then we do the same for the model. We concatenate all these, including our encoded make and model, into a features column. And again, we're just appending all these, adding them to the pipeline. Nothing's happening yet. We're just setting up what we want to happen. So then we've chosen this normalized min-max on the features. And then we choose our trainer. So again, we can, if you use IntelliSense, you do ML context regression, which is our task, and trainers. You can see the list of trainers. I'm sure that you all would have chosen, may have chosen other ones that we didn't choose. And then we appended that trainer to our pipeline to create this training pipeline. And then once we called that fit method, we actually chose our training set from the train test split, and we fit on that data using our pipeline and got this model, which is, we just have var here, but that's going to be that iTransformer that that Louise mentioned. Was there anything else you wanted to mention about this code, Louise?
No, and if there's any questions, please ask them. But no, there's nothing else I can add to this.
Awesome. Okay. So let's talk about evaluating your model. So there's quite a few different evaluation metrics. Before you use your model in production, you want to make sure that it's performing at a level that you deem acceptable. And so obviously this can depend on your scenario. If it's, for instance, some sort of medical scenario that you need to have a really high accuracy, this will be a lot more important. But if it's, for instance, categorizing comments that, a few here and there that go in the wrong category is okay, then you don't need to have it as close to 100, it can be a little bit less, around 75%, 80%. A lot of people they ask, what is a good accuracy? And that's really going to depend. There's not one good accuracy or evaluation metric for your particular scenario. So depending on the ML task that you have, there's going to be different evaluation metrics. I've listed them all out here. Again, we'll be giving out this slide deck so you can see these. This is also all in our docs, so we'll link to it in our docs. But you can see for classification, we usually look at the accuracy. The closer to 1, the better. Or if you're doing in percentages, the closer to 100%, the better. Regression, we look at the R-squared metric. Same for recommendation. There are more evaluation metrics per task. I'm just listing the most commonly used one. You can definitely look at other metrics and use those to base your performance off of. And so you see clustering is average distance, ranking, and anomaly detection also use different metrics here. We've just chosen what we think are the most common evaluation metrics. So in this case, our task is regression, so it'll be that R squared that we're looking for. So then we'll talk about underfitting and overfitting. So an algorithm or a model is underfitting when it can't capture the underlying trend of the data. So it means that our model is too simple or doesn't fit the data well enough. So you can see an example here. The model is just too simple and can't capture that trend of data. To prevent this, you can do additional feature engineering. Louise talked about that a little bit before. You can try removing noise from the data, try out different algorithms, try tuning different algorithm options. And if you want to learn more about these types of things, I'll talk about overfitting as well, but I believe I saw Justin on the chat there. He's actually a data scientist at Microsoft who can answer a lot of these types of questions. And he'll also have that Q&A tomorrow. But then you also have overfitting. So I believe Louise already mentioned this and talked about what overfitting is. It's but when the model doesn't generalize well from the training data. So it fits it too well. And so what this does is you could get a really, really high accuracy, such as 100% or even 99% or something like that. And you're like, oh, wow, this is great. But that's actually not great because that means that your model is overfit, especially if it's at 100%. And again, it's kind of like Louise's analogy was really good about memorizing answers to a math quiz instead of knowing the actual formulas. So yeah, you'll know those answers, but if you get a different type of data, then you're not going to be able to generalize. So that's how I would describe overfitting. I saw this quote in this article. It says, overfitting can be pretty discouraging because it raises your hopes just before brutally crushing them, which I think is really, really funny. But here's a few ways to prevent that. Adding more training data can help with this. Removing features that may be duplicates of other features, such as if you're trying to predict housing price and you have zip code and address or something like that. They're kind of very similar. They're both locations, so it may be actually hurting your case to have both. And then cross-validations, which I'll explain in the next slide. So cross-validation is a method of model training and evaluation. It's in contrast to that train test split that we showed. So instead of splitting your data into a training data set and a testing data set, this is another way that you can do it. So what it does, it folds data into partitions and trains multiple algorithms on these partitions. So it really improves robustness by holding out data from the training process and can really help with that overfitting problem. And it is also really great to use for smaller data sets. So then, again, Louise mentioned this earlier, where you want to be able to explain your model. There's a few different ways that you can do this. I'll talk about global and local. So global explainability is when you want to look at the entire model. So what features does the model give more importance to in general? Local is individual predictions. So that would be specific sample data, like why was this person rejected for a loan? So you're looking at specific predictions that were made and why those predictions why that particular sample prediction was made. So MLNET offers a few techniques for model explainability. We have permutation feature importance, or PFI. This is used for classification and regression. The way that it works, it shuffles data one feature at a time, and then it calculates that metric or the performance of each feature. So the larger the change, the more important the feature. So if you get rid of one feature, how does that change the accuracy of the model? So this is, I believe this was on our blog post or one of our docs, where you can see when feature 10 has the most importance because it decreased the accuracy by, I think that's 0.35 by the most. So as you go down, you can see this is how they ranked the importance of each feature. You're looking at feature contribution calculation, or FCC. Again, this is used for classification or regression models. This actually works by determining the amount each feature contributed to the model score for a particular data sample. So it shows which features are influential for a prediction on that particular sample. If we're looking at, for instance, that taxi fare prediction, this is actually in our samples GitHub repo. We have a model explainability sample. You can see trip number 2, which is a particular prediction that it made. You can see trip distance contributed this much to this particular prediction, and then this is what trip time contributed, and passenger count. So those are a few of the ways that you can explain a model and try to get more of a visualization of it as well. And then there's improving your model. So there's quite a few ways that you can improve your model, potentially. So providing more training data is one of those ways. Doesn't always work, but it can definitely help. Filtering missing values and outliers, I think Louise mentioned that one earlier. Feature engineering, selecting different features, that can be including more or less, or more relevant features. Choosing a different algorithm or tuning those algorithm hyperparameters, or cross-validation. So again, each one of these points is not guaranteed to improve your model performance. You may need to have different combinations of each and try out different things. But these are just some of the ways that you can. Looking at our tooling in AutoML, again, AutoML is used to speed up that experimentation progress of the algorithm options, evaluating, and that cycle. So you can use the model builder in VS or the CLI, and I've got it by ML tasks. So for classification, you can use model builder and the CLI for local AutoML to speed up that process. For regression, you can use both model builder and the CLI for local AutoML. And then image classification and model builder has both local and Azure AutoML support. And there's now the recommendation task in our tooling as well for local. All right, so now our next task is to evaluate our model. So we're going to use the R-squared metric for this. Like I mentioned, that's really common to use for regression tasks. And optional, you can try training with different algorithms to see if that R-squared metric changes. So if you want to try different algorithm or different trainers for regression, you can see how that makes R-squared go up or down. You can also try messing with or tuning the hyperparameters of the algorithm. You should be able to use either IntelliSense or go to our docs API reference and see what the different options are that are offered for each algorithm, and you can try changing those as well and see if that changes your R-squared value. So go ahead and start this phase. Again, you can go to this AKA link and it'll have the step-by-step for you. And we can start with questions again.
Perfect, absolutely. So we have one question from Rutix here. Is there a specific reason why image classification is not available in the CLI?
Just timing. We just haven't released it yet. We're actually working on that now. I don't believe it'll be in the next release, but I think possibly the next one after that. No promises about when it will be, but we are working on it now.
Awesome.
It was just a bit easier, when you're working with images and it's very visual, so it's a bit easier to implement in the UI first versus having it in the CLI. So
perfect. Yeah. Question. And this is a question from me, actually, myself here. You mentioned the hyperparameters, and for people getting started with machine learning, that may be a scary phrase and term. Can you kind of explain what that means?
Yeah, so all the different algorithms we have different options. I wonder if I guess I can go to our docs and show it while we're all working. Let me move over to here. So if we go to our docs and go to our reference, thank you, Louise, for creating these wonderful docs for us, by the way. So actually, he may know better where I would be able to find examples of these options. Should I just go to the reference or?
Yeah, you can go to the reference and we can look at, for example, if you can look at the clustering or regression is fine as well.
Let's go to regression log. We'll look at the different trainers that we've got. All right, so you can see we have all these trainers. Let's just choose this one. And you can see here, we've got these dot options. So here you can see that this algorithm has these options that you can change. Again, I don't have a data science background, so a lot of these, we have explanations for, like basic explanations, and you can try different combinations of them and, seeing if increasing or decreasing one can help. But I believe we use like a default. So if you don't specify any of these fields, then it'll just be default values that we've chosen. Louise, is there anything you wanted to add there?
No, that's you got it spot on, right? And kind of like to make the distinction of the hyperparameter versus what the parameters that the model is learning, right? The parameters that the model is learning are specific to the data, right? It's learning from the data, and then these hyperparameters, kind of what the name implies, is they're outside of the algorithm itself, right? So it's values and settings that you can use that don't necessarily that aren't necessarily part of what the relationships in the data represent, right? And kind of to add on to that, right? You have the defaults, kind of like Bree said, but AutoML, that's exactly what it does, right? So you might think, like, when you're looking at the outputs that are coming out from in the CLI or a model builder, the only thing that you're going to see is like, oh, it tried the light GBM or it tried SDCA. So you're going to see the algorithm. But actually, in addition to trying different algorithms, it's trying different hyperparameter combinations for those algorithms. So that's this step here. Like, you could literally sit here and try, example weight column name, and then put one, or what's it called? Your L2 regularization, you might try 0.1 and then 0.2 and 0.3. So instead of doing that, right, AutoML automates the process of picking these and optimizing these hyperparameters for you.
Thank you, Lisa. That was a fantastic answer, I think. And Bree as well.
I see that this modeling is really showing the age of my PC. I see that comment. Yeah, I try streaming and sharing your screen and trying to run the CLI and model builder. It's definitely not. It's been made my computer a bit slow today, but that's okay.
I remember when I started myself with image specification on my local PC, and I got a Dell XPS with 32 gigs of RAM, and the computer shut down. It got too warm.
Hate to see it.
but that's why you can fan out to Azure Machine Learning, right?
Yeah, with image classification specifically through Model Builder right now, you can do that, and you don't have to take up your local resources and continue coding or whatever else you want to do. While it's training.
Yeah, I have that same machine, but I have fans going under it to help cool it even further.
Might need to invest in that.
On the positive note, if you live in an area where it gets pretty cold in the winter, you can kind of save on your heating bill by just training machine learning models.
Are you saying that's what you're doing, Luis?
That's exactly what I'm doing.
I guess that's why companies move their data centers to like Iceland as well, and to cold countries. Save on the heating bills there, and save on especially on the cooling bills, I guess.
Or underwater.
So while you're working on this, I have a quick question for everyone on the stream today. Please put in the chat where you're from, where you're located, where you're viewing from. As we said before, we have speakers from all over the world, but I also want to hear where you are from. Do we have any from Europe and Asia and Oceania and North America? Where are you all from?
You've got the Netherlands, Milwaukee, Italy, Romania, Belgium, wow. Czech Republic, Ohio. Oh, hey, Seattle. Austria, wow, this is crazy. Georgia, oh, that's where I'm from.
I suspected that would be all over the world there.
Yeah.
It's fantastic.
Texas, Iran, wow.
I'm North Carolina myself.
All right, Edison. I'm actually not too far from Edison.
Poland and India.
Anyone from Scandinavia on the line? Sweden, Finland, Norway, Denmark? I'm Swedish myself. Have to ask.
Canada. Wow. Norway. We got a Norway.
All right.
Yeah, I'm feeling this phase this task will take a little longer depending on everyone's machines. Thanks, Justin, for joining the chat. As he's answering some questions, appreciate it. Super looking forward to the Q&A with you tomorrow. It's going to be awesome.
Yeah, you'll get more time to pick Justin's brains.
Yeah.
Absolutely. And if you also want more kind of data science conferences and talks, I know that Håkan here from Norway is actually speaking at an Oslo conference, I think, on Tuesday next week. It's also a virtual conference, so can check that out as well. I think he's doing 2 talks.
Very cool.
Yeah, when you all are done with training, let us know in the chat so we can get an idea of when it'll be good to move on. But no rush. All right, we've got, let's see, task completed. We've got R squared of 0.89. Awesome. And then over here, R squared 0.895. Awesome. Looks like you're getting very similar results. And then if there's anyone that ran into trouble with training or it's been training for like a really, really, really long time, let us know as well. Or if you're having trouble somewhere, we can try and troubleshoot. It's interesting. This is trying to figure out how to make a workshop online, because usually, you have people walking around the room and able to help one-on-one. So we're really trying to adapt to all these all digital, all virtual formats. Which I'm sad that I don't get to talk to you all, but that's okay, I guess.
Yeah. So yeah, that's very true. It's a challenge. So any feedback, good or bad, as we mentioned earlier, we'd love to hear it because we definitely just want to make this better.
Mm-hmm. And we can't really read the room, so. All right, I see lots of people have completed the task. They're sending us their R squared. Looks like everyone's around 0.895. Awesome. All right, Alexander and Louise and John, you think we should move on?
I think so, yeah.
Cool. Okay, quick review before moving to the next section. All right. So before we had finished that training where we fit based on our training data, so then what we've done here is created our train set predictions and test set predictions in the iData view using this transform method, because what we want to do is evaluate. We're going to calculate these evaluation metrics here. So train set metrics will regression.evaluate. We choose our train set, our label column name, and our score. Score is going to be the output returned by the model. It's going to just be that value. We do the same here, test set metrics. And then what we want to do is print out our R squared for our train set metrics and our test set metrics here. So we printed out that R squared. You can see once you do this transform, and then you can actually evaluate based on that iData view. And then you could take that train set metrics, and if you use IntelliSense or again our documentation, you can see what metrics are available for that. So in this case, we had our R squared. And then we've got this optional cross-validation here as well for people who want to see how that works. R squared. All right, so let's move on. Hopefully you all got something similar. It looks like people got around that point, was it 0.895, so that's great. So the next step is actually going to be to save your model. This will be it should be really simple. We talked about this already, but an ML.NET model is just a serialized zip file that contains the data schemas, transforms, and algorithms. You're more than welcome to unzip it and check what's in there, but it's not really human readable. So once you save it, you'll have the zip file that you can save in your project, and then we'll move on to the next step of consuming after this. Very simple task, just one slide of explanation. So if you go to this phase 2.4, it'll actually show you that code as well. The next task is just to save your model to the same folder as your project.
So once you saved your model, right, Bree, then you can actually use it and consume it in different applications, as I'm sure we'll see more of later here.
Mm-hmm. Yep, exactly. So our next, we've got a break after this, and after the break, that's when we'll move on to our model and consume that model in a different application. The first step is to save it. But yeah, then you can use it in all your .NET applications.
Pretty cool. I think one of the really cool things with .NET as well, just to weigh in here, is that you can actually use it in your .NET applications. Like you can actually call it in an ASP.NET Core application, Azure Function, desktop app. You don't need to have it. I mean, you can definitely have it in a Docker container as well and scale it there in a cluster, but there's no need. You can actually have it like completely seamlessly in your app.
Yeah, definitely. There's a lot of different ways, just depending on what your needs are and what your app is. And I think we have a slide on model deployment that Louise will go over a little bit later. And again, once you've done with this phase, feel free to send us a thumbs up or a done. Hi from Spain. Or I guess hi to Spain.
Yeah, I guess Spain, India, Canada, Norway, Russia.
Russia, yeah.
Lots of different countries. That's awesome. How many on the stream today attended MS Build? I heard some number from somewhere that there was 252,000 people that registered or something.
That's crazy.
That's what I heard, yeah. It's wild. But at the same time, right, it allowed us, it allowed folks to take part in these conversations and take part in these sessions that otherwise any other year they wouldn't have been able to. So, that I think that was the biggest takeaway. And the way, of course, as with any of these virtual events, it's a learning experience, and there's challenges, but I think overall it was fairly successful.
Yeah, it was a lot more real. When you're doing a presentation on stage in front of people, it's really, it's literally staged, right? It's a presentation, and you have your presentation voice, and it was really interesting to see people in their own homes presenting, in a more comfortable environment, more casual environment, made for a very different build. I really liked the change. It was really cool to see.
I know that we had a lot of people in my team, for example, as well, that we used to have a lottery among the company where we had like a lottery who had to go to build every year, and we don't have too many, of course, and every year we sold out the tickets. So it's amazing, I think, for everyone in my team as well to be able to attend as well and view into sessions and get all the content. All right, I think people are getting ready here in the chat at least. Wait for a few more, I guess, before we kind of move on here, but.
Yeah, I can move on to the review so that people could see what that should look like. All right, so this is the review for this section. I added just a console write line just to show that it got to this step. And then again, getting that ML context.model.save. You're saving that model schema of the training data, and then specifying where I want that file path to be. I believe we have it up here. So we've specified this model file path and input it in here. So one line of code to save the model. and we can move on. All right, so now we've actually got a 30-minute break. Again, I put another little machine learning joke that I found online. Hopefully by this point, if you were not super familiar with the machine learning, you get it now. And yeah, we can, let's see, what time is it right now? 10:30, so we can pick back up, well, sorry, it's 10:30 Pacific time. So in half an hour, which would be 11 a.m. Pacific time, we can pick back up. I'll be online a bit to answer some questions, and I'll probably take a little lunch break and then be back. So if there's any questions about anything ML.NET, anything machine learning, Microsoft, anything that we've talked about so far about training the model, or anything about Malibu, feel free
what
to
you're
ask.
doing this weekend. Yeah.
Or yeah, you know.
Yeah. What are you all up to this weekend?
Hopefully
watching the conference.
staying home and watching the conference, yes.
I will join you all here with me and John as well. I think John is taking a break already, but I'll be here as well to answer any questions or just chat in general about this awesome conference. We've been streaming for I don't know how many hours now. 2 hours, 3 hours.
Yeah, that's great. All right, looks like Steve's doing some yard work. That's great.
That's great. So we have a question here. When retraining a model, do we supply an existing model along with more data?
No. So you will just, I believe that is a machine learning concept where you can train on top of a model that you already have, and somebody can let me know what that's called. So, do anyone on the call know? I know there's a term for it.
Transfer learning, or
no?
are you thinking about
parameters? Is that what you're referring to?
No, it's when you maybe Justin, if he's still online, he can answer. But it's when you already have a model and you don't want to retrain the whole model, but you add more data and then kind of train on top of that. I forget what it's called. You can't do that with ML.NET right now. So you won't supply it a model. You'll just retrain the whole model with the data, so you don't have to supply the model. Oh, transfer learning. Okay, yeah, maybe that was it.
Well, I think to a certain extent you might be able to, but it's limited to some scenarios. So what you can do is for retraining, there's actually in the docs, if you search, there's some algorithms that kind of allow that, right? Where you take the parameters that you can extract what it's learned from the different models, and you can just supply the previous parameters from the model that's already trained, as well as the new data that you want to train on. And I think that does get you kind of where you want to be, right? Transfer learning is I think it's called online learning. I think it's called, or something like that.
Mm-hmm.
Yeah. Transfer learning is a little bit different. Transfer learning is more like you're doing different data, right? So you take a pre-trained model and you're using different data other than the data that it was trained on to solve a different but related problem, right? Whereas online learning, it's you still use the same schema of data or the same type of data to solve the same problem. You're just incrementally training your model.
So question here, so for retraining, do you add more data to existing data to retrain, or how does it exactly work? Will you be demoing that here today? The answer is no, I guess, not demoing.
No. We won't be demoing the retraining piece, but yes, you would provide more data. So the way that it works, you could think about it, right? Like it's like, okay, you train your model last month, and there's a lot of things that change in your business or with your application, whatever it is, wherever it is that you're deploying your model over a month, right? So this month, it's like, okay, well, I want to train my model on the new data. So you take your existing model and you provide the data for the last month, and you use that to retrain your model, right? So yeah.
And I think Vishal, I completely agree with you as well, and I think probably Luis and Brie as well here, that the majority of machine learning is preparing the data or working with the data. That's what takes time, and rarely will you get as clean data as being provided today, I think, during the workshop. There's a great actual blog post out there I read about the maturity of organizations when it comes to machine learning, on this kind of triangle of like being able to capture data and having a good process for that, and how you actually store it and work with it so it would work for machine learning scenarios in the future.
Yeah, and we can provide links to, like I think you said, those blog posts or any documentation, this preparation of data, because that definitely is one of the hardest parts, especially when you have automated machine learning that will choose the algorithms for you. It's really just figuring out, one, the type of problem that you have and or the type, how ML can solve that, mapping it out to that ML task, and then preparing that data to make sure that it can actually work.
Yep. So asks, is the machine learning all about prediction? When is it to use ML and when is it not necessary? So when would you use ML and when it's not necessary to use ML?
Louise, you want to take this one?
Yeah. So when would you want to use ML? You would want to use machine learning in situations where, well, to be honest, you would want to use it wherever possible. But again, you can't, what is that like when you're a hammer, everything looks like a nail. You definitely don't, you want to use it where it makes sense, right? If it's going to take a long time for you to build a pipeline to get your data and to, do the data transformations and stuff like that, for something in terms of like that would take a very short amount of time for a human to do, maybe ML might be overkill and not necessarily suited to your problem. But if it's something that is time consuming and that it's keeping you, or if you're working in a company, if it's keeping your organization and your team from focusing on the real work. So like a perfect example, right, is it's machine learning, and it's actually being done a lot, is in the hospitality industry, right? So let's say you have a hotel, right, and you want to book reservations for a hotel or book reservations for a restaurant. Now you could have somebody who is there just answering the calls and being like, okay, when do you want to stay, and what dates, and how many people and stuff like that. And you certainly could have that, right? But could you instead have that person focusing more on the experience of your guests? Or at a hotel, right, could you have that person who would otherwise be taking calls focus on making the experience of your customers better, instead of spending their time answering phone calls, right? And that's where you would have some sort of automated agent, a chatbot, something like that, that would, somebody can just go and automatically interact with this agent. That way, the person who was doing that task before could again focus on making sure that let's say that that particular user likes this particular type of flower, and therefore you have that flower, you put a bouquet of those flowers in their hotel room or something like that, like making sure that their experience is better, and in doing so, right, you're freeing the person that was otherwise doing this task to do something that might be more meaningful for your business and for the experience of your customers, right? So that's an example of where I see ML really, really playing a large role, right? Like sort of working in tandem with humans to free up humans to perform these other sort of higher level or more impactful tasks.
Yeah, I can vouch for that hospitality example. I used to work front desk at a hotel, and there were times where I had 5 different phone calls and 10 guests up at the desk, and something like that with machine learning really would have helped. And actually, sorry, I want to show, if you go to .net/ML, so this is our just main landing page, we actually have a few stories of how people are using it in real life, and we'll have some of these people talking about how they're using ML.NET and their real use cases. But if you wanted to see some of those stories, this is actually like how they, like what was the business problem they were trying to solve and how they used ML and ML.NET to solve it. So you can read through some of these stories. We're always working on adding more stories. Just added 2 more recently, and I'm always looking for new stories. But yeah, so this could give you an example of ways that you can use machine learning, or problems you can solve with it. Also in our GitHub, so .NET/machine learning samples. This can also give you a little bit of an idea. Again, these aren't like real world because it'll be, sample data sets and such, but it's still examples of, sentiment analysis, spam detection, credit card fraud detection. So these are very real problems that otherwise would need to be solved by a human, manual task that can take a really long time, cost a lot of money. But in this case, if you get a machine to do it, you get rid of that aspect and you can save a lot there.
Cool. Yeah, and to add to that as well, Bree, a teaser for tomorrow is that those, use cases that you showed on the page there, we actually have interviews with some of these tomorrow to kind of showcase how they use it in their organizations.
Yep.
And that'll be fun. And for anyone who just joined here, we are currently in a 30-minute break here, starting up at the full hour for the rest of the workshop. If you're wondering why we're babbling about different things that doesn't relate to the workshop.
I saw someone ask if we could share samples about forecasting. So we have this time series forecasting, which is sales forecasting example. If you go to our docs, we also have a step-by-step tutorial. So we've got tutorials here. If you go to API tutorials, you can see all the different tasks or scenarios. In this case, our forecasting bike rental demand is the scenario. So, yeah. All right, looks like the questions have slowed down, so I think I will hop off the online for a little bit, grab some food, and be back in 15-ish minutes, maybe 10.
That sounds good, Bree. And at least I will stay around for questions, and maybe John as well. Louise, definitely feel free to take a break if you want to get something to eat or drink. And
yeah, we'll do.
Sounds good. And John, I definitely want to talk to you at least about tomorrow, what's coming up here. We have 9 speakers, right? Starting at 10 a.m. Eastern time here in the US.
Yep.
Who do you... I guess we're starting off the day here with an AI ethics talk by Henry Gia. It's going to be really interesting to see. It's going to be, I guess, not so much ML related, but it's going to be more an overarching talk, agnostic of what library you're going to use. Mm-hmm. And talk about things to consider, I guess, when training models, about the ethics about things and about being responsible when it comes to using machine learning. And then I think at 11 we have Journey Kafka. He's from Australia. I believe he's in Brisbane. And he's going to talk about kind of MLNET on an introductory level and give us a good start off there. And he actually spoke at, I think it was NDC Porto not too long ago. And gave a talk there, which was very much appreciated. So that should be a really, really good one. So I'm looking forward to that. And then what's coming up at our lunch hour? What's coming up at 12? John, do you remember?
We have the Q&A with the Microsoft data scientist with Justin Ormont.
Exactly, yeah.
I believe he's also kind of part of the ML.NET team as well.
Yeah, and I think you are already seeing him active in the Twitch and YouTube chats right now, answering questions for you also. Thank you, Justin, for jumping in there as well. That's definitely something you should consider. We have a channel in the community Slack dedicated for this. I think it's called Ask a Data Scientist or something like that. So if you already have questions that you want to ask Justin, like really in-depth questions, make it hard for him, definitely post them there. You can also post them live tomorrow during his Q&A session, and we'll ask him directly during the session. It's up to what you prefer, I think. But definitely check that out. But yeah, following Justin's Q&A session, we're going to go to Luis Beltran, and he's a Microsoft MVP, and he is going to, I think, be speaking about transfer learning and deep learning, which is going to be really interesting, I think. It's going to be, I think, a good topic to get people settled with that as well and get introduced to that. And after Luis here, we're moving on to Daniel Cosea, and he is, I think, currently in Holland, so a European. So any Europeans, you get representation there. He's also a Microsoft MVP and a trainer, and I think he's given over 1,200 hours of developer training, so that's going to be awesome to see his talk. I think it's about Jupyter Notebooks with ML.NET, which is going to be interesting to see. And then following that, we go into move into to Bart. He works for Microsoft as a principal architect, and he's going to talk about I think decision analysis with ML.NET and Blazor. So anyone, I've seen a few questions on the chat today about Blazor and ML.NET. So if you have those questions, that's going to be an interesting talk to join into and kind of see how those two can interact with each other, and I can use the model in a Blazor application. So definitely do that as well. And then at 4 o'clock, do you remember who comes up at 4 o'clock? I'm calling you out here, John, but...
No, it's Veronica talking smarter chatbots with ML.NET.
Yeah, and do you remember where Veronica is famous from?
I don't, actually.
Yeah, she was actually featured in MS Build last week. She was during, I think, the Skype call with Satya Nadella and with Scott Hanselman. I think during that session there, she was on that little call there for a bit. It's really cool.
Oh, nice. I might have missed that part, actually.
I missed it too, but I saw it later, and I guess that's something fun to say. You're famous from Build. That's pretty cool to say.
Yeah.
But she's going to talk about...
Right there.
Yeah, exactly. She should have that. But that's going to be a great talk. I'm really excited about that talk. And then we are going to get Praveen. He's going to join us after Veronica's talk. He is living in India, a cloud architect and avid community speaker, who's going to give us an introduction to data frames and so forth. That's going to be really fun. Looking forward to that. And we kind of moving around the world here. I mean, Veronica is in the US and Praveen is in India. And what is coming up at 6 p.m. Eastern time here after that?
Our last talk will be from Will, talking about serverless machine learning APIs with Azure Functions and ML.NET, and some Cosmos DB in there as well.
Yeah, I think that's going to be great. I really like to see these kind of applied talks. I mean, we are getting a good workshop today on the foundation of ML.NET and how we can use it and all the concepts, which I think is super, super helpful. And tomorrow we're going to go into more of like applied cases, like how do you use it with Blazor? How do you use it with Cosmos DB? How do you actually do the data exploration we're talking about here with Jupyter Notebooks and the data frame API and so forth? There's just a huge ecosystem out there and so many use cases that it's of course impossible to cover in a workshop, but during 2 days we can try at least.
And it kind of shows how versatile you can use ML.NET, chatbots and the web and all that.
Absolutely, yeah. It's fantastic, I think. And yes, you mentioned Will, right? Exactly, yeah. And that's going to be the last talk of the day tomorrow. It's going to be quite a ride. I mean, there was so many fantastic submissions and proposals to this conference, and we're sorry we can't show you all at the same time here. But we're hoping to have a follow-up event at some point in the future as well, to show more use cases as well, more talks. And if you're joining in the audience today as well, definitely consider submitting next time and consider different topics you want to teach. I think that'd be awesome to see. And in general, I guess as well, right, John, if anyone wants to learn more about ML.NET, I always recommend the community samples repo on GitHub. That's it's going as a repo to get started with. And John, I know you are a very, very productive YouTube creator as well for ML.NET videos.
I try.
Yeah, you try. I think you have. You tried really well in that case, I would say.
Yeah, there's a few of them out there. Working on some more, actually.
Cool. Yeah, I mean, I really enjoy watching your videos, John, as well. And I personally, for some people on the stream today may know, I stream as well on Twitch here, and I teach ML.NET on Saturdays and Sundays in different aspects. Usually on Saturdays I go into kind of teaching ML.NET from the ground up, and on Tuesday I contribute to an open source repo I created for ML Ops in ML.NET. And we'll talk about more about MLOps, I think, later in this workshop, I believe, which is a really cool thing. So if you're used to DevOps, for example, for software engineering, MLOps is the equivalent, but how to automate your machine learning training process and put that into production and register your models and so forth. And there's currently no good way to do that in ML.NET. So we're building our own tool from scratch. And we would love your help. So if you want to help out with that, definitely check that repo out.
Yeah, I've been following along with that on the stream, and it's fun to watch, and plan on contributing myself.
Yeah, I look forward to it for sure. It's a really fun thing to work on for sure. And I can share a link to my stream here. Yes, I got a question on the chat about a stream link. I'll do that if you want to. No, it's a. So John, can you tell me a little bit more about when you got started with ML.NET here? We have 10 more minutes of the break here, so can you share your story?
Oh, yeah, I think I mentioned at the beginning, as soon as was it 0.1 version was announced, I started messing with it. And one of my colleagues at Untitled was messing with it as well, and just kept playing with it. And I think that's soon after that is when I did that first video on YouTube, and that kind of blew up. And I've just been following the repo ever since, and just having fun with it.
Yeah, I mean it's fantastic, right? I mean, I always wanted to get into machine learning myself. But I was never kind of presented with the opportunity at work. And when ML.NET came about, I was intimidated in the beginning because it was, a lot of new words and other things out there. But after a while, I felt like it was comfortable to do, and it's definitely a great way to get started with machine learning for sure.
Yeah, definitely.
Let's see, I'm sharing some links here in the chat here for both the repo for MLOps.net, that's called, if you want to contribute to that. And I'm also showing my Twitch stream if you want to join me some other day of the week. Unfortunately, you won't be as fortunate enough to have Bree and Luis on my Twitch stream, so I'm happy you can enjoy the expertise and experience here, which is good. Yeah. Now, I remember I think I started with ML.NET about a little bit over a year ago, and I gave my first talk on that at the JetBrains.NET Online Day a little bit over a year ago. And I remember prepping so much for that talk, and the audio when I gave it was horrible. And all the tech checks before was working really well, but then actually doing it live was not a good thing. But it was great getting started with it.
Yeah, I'm looking forward to the roadmap and seeing what all is coming up next.
Yeah, I mean, 1.5 was released, right? Just a few days ago this week.
Yeah, a couple of days ago.
Anything in there that you kind of want to mention here to the audience as well that we should check out?
For the new release? Let's see. There's been some documentation updates, that's for sure. And I think somebody mentioned the Onyx stuff. There's a lot of Onyx export updates added to that. And like Bree said, they're continuing to improve that as time goes on.
Yeah, absolutely. This 1.5 release has definitely, I think, been in preview for quite a while. But it was great that it actually finally went live now as well, which is really good. I think some of the things I'm really excited about this last half year, at least with ML.NET, is the Jupyter support and the C# kernel there, the .NET kernel.
Yeah, that's definitely nice to see.
Is anyone here on the stream today actually using Interact for your Jupyter notebooks? And if you don't know what that is, that's completely okay. It's a very small software. But it's something I can highly recommend if you want to do like Jupyter notebooks to explore your data and visualize your data. You can do that by, of course, downloading the Jupyter bundle and kind of go about it the regular way. But there's also something called Interact, and I can put that in the chat. And let's see, I use it a lot. It's I think it's a startup, and it works really nicely with the .NET kernel, and it's like a desktop application for you. So that's highly recommended.
I haven't used it myself. I usually keep with the Jupyter Lab.
Yeah. Jupyter Lab is great. I have nothing against Jupyter Lab. I just don't know. I kind of like some of the presets and stuff like that with Interact. That's why I use it. They have dark mode.
Well, they have that on Jupyter Lab now.
Oh, they do? Okay.
Yeah.
Here you go. So from the audience here on the stream today, we are going to start in about 6 minutes again with the workshop with Bree and Luis. But before that, I want to hear kind of what talks you are excited about tomorrow. Which ones are ones that you are definitely going to tune into? And I realize that depends on time zone and availability, of course, but share your schedule, I guess. Welcome back, Bree.
They will be recorded if you can't make them all, of course.
Absolutely, yeah. They will be recorded and put up there. That's, I guess, the best part of organizing the event, right, John, is that you get to watch all of them.
Yeah, exactly.
All right. So, Bree, we've been talking about tomorrow here and which talks are coming up and which areas that people can dive into. And we're asking on the chat right now which ones the audience are looking forward to. And then Clarence just put in here that Veronica's talk is one that he will be joining for Even Smarter Chatbot.
Yeah, I'm super excited for all of the sessions, really. Like, to see everyone so passionate about ML.NET is really, really awesome. And I'm really excited to see, everyone that attends the conference. I think I said this before, but to see what comes from it and what people create with it and the problems they solve. One of my favorite ones, I believe, Mihai will be talking tomorrow a little bit about how he's using ML.NET, but he's literally helping save the environment with it. I don't want to reveal too much, but yeah, it's really, really cool. So I'm super, super excited. And then, also excited to iterate on this workshop based on the feedback that we get and just educate more and more people on it.
Absolutely. And I think one of the things we talked about as well that I definitely want to do is hackathon for ML.NET.
Yeah, I remember we had mentioned that. We thought about doing it part of this conference, but we're like, well, there's not enough time. So that could definitely be our next step is a hackathon if people are interested.
Yeah.
I see someone asked about the T-shirt.
Yeah. So I think, John, right, you are considering at least doing it. So the one who's the brain behind these T-shirts is definitely John. He made sure all of us have these amazing T-shirts we're wearing. I love ML.NET, and I think he even made one for your, was it daughter or son, John?
Well, my wife embroidered a onesie for my daughter.
Oh wow, handmade. Okay.
But it does say I heart ML.NET on it.
Exactly. But I think, John, you're considering at least maybe doing some kind of custom ink order on that.
Yeah, I'm looking into it.
We'll see. We'll see what happens.
Do like a bulk order so everybody can get something shipped to them.
Yeah.
So when is this hackathon happening?
Yeah. we're just putting the idea out there.
And
Sorry.
I was going to say the next time I wear this T-shirt, I'm going back to T-shirts. It's going to be a tank top. I wanted to do it for this one, but didn't get the chance to. So
yeah.
Mine's still in transit, so I unfortunately couldn't wear the uniform.
That's it. That's the uniform. Yeah. And Rutix, yes, all the sessions tomorrow will be recorded individually, and they will be uploaded both to the YouTube channel, but also I think to a Microsoft site potentially as well to be viewed later. But we will definitely share that. We will send out an email as well to stay tuned for that with links to recordings maybe on Sunday or Monday. So that should be good. Cool. Well, any other questions, I guess, before we get started back in the workshop here? Ree and Luis, do you have a chance to get something to drink and eat?
Yeah. So we're refueled, ready to
Feeling a lot better.
finish up with.
Awesome. Yeah.
Perfect.
She's shy today. She's shy now after the break. So. All right. So I guess we're at time. So we'll go ahead and get started with the next section. So this is going to be. Hold on, my computer's a little slow. So next section is going to be about consuming a model. And Louise, this was you as well, if I remember correctly.
Yep.
Showing.
I'll be taking us on a journey.
Is not, hold on. Sorry, PowerPoint just crashed.
No worries.
Technical difficulty.
Yeah. In the meantime, I'll just say that I will take you on this journey through consuming the app, and I guess we can review in the meantime. So what we've done so far, right? We've gone through the model training or the model production, model creation phase up to this point, right? So we have gotten our data, we prepared our data, we've trained a model, and we've saved that model for later. Well, we've evaluated it to make sure that it's good. And I think most people got like an 89%. And after that, we went ahead and we saved our model so that then we can use it inside of other applications, right? So that's a step that we're at now, where we're going to take this model and we're going to deploy it to ASP.NET Razor Pages application, right? Or ASP.NET Core Razor Pages application. Which is one of the deployment targets that ML.NET provides us. So, that's really one of the really nice things. So, you're seeing that from a .NET perspective. .NET is a very rich environment, and .NET has a lot of deployment targets. .NET has a lot of opportunities to essentially let you choose where you want to deploy your models, right? And the fact that it's cross-platform, the fact that it's cross-platform, the fact that it's open source, it really gives you that ability to really deploy anywhere. Do you want to deploy it on an IoT device? You want to apply it on a Linux PC, right? On a Linux server. The choice is yours, right? And that's one of the really nice things that .NET provides you as an ecosystem. And best of all, right? Like, this is something that's incremental. And it's incremental, and you don't necessarily adopt it into your application as you see fit, right? So I think
you're back up and running with the PowerPoint.
There we go. Like my ad lib there.
Yeah, I was going to say that was really good stalling. I liked it.
Thanks. So in terms of consuming our model, right, there's different phases or things that you might want to do. And the first one is create a model output schema. So very similar to how we went ahead and created a model input schema to define what the input or what our data look like. If we want to at some point manipulate and have access to the predictions made by our model, we need to also define a model output schema. Okay. So depending on the task that you use, there typically are some default columns that are already associated with the algorithms or with the output produced by models for specific trainers, right? So in the example here where we have binary classification, right? Binary classification by default has a predicted label, which is a Boolean, true or false, and that's your prediction. Is it 1 or 0? Is it true or false? Right? You have your score, which provides you with the probability. How likely is it? So if something belongs to a particular class in binary classification, remember there's only 2 classes or 2 categories. The probability gives you the score gives you basically what the probability of having a true label is, and the probability. Sorry, are these mixed up a little bit? Well, either way, so what the score provides you is the ability to tell how likely is it that it's this particular class, and then the score also gives you the likelihood that it's that class as well. And you see the same across all the different tasks or categories, right? So you have multi-class classification. And with multi-class classification, you also have a score, except that in this case, it's a vector or an array. And that gives you all the probabilities or the likelihoods for all of the classes, right? Where the highest score is the predicted label. Okay, so yeah. After that, what you want to do is you want to go ahead and you want to load your model. Remember that we saved it in the previous phase. We saved our model to a file. So what we want to do is we want to load our model. And once we've loaded our model, you can choose how you want to make predictions, right? So if you're looking to make predictions, there is this convenience API called the prediction engine. And the prediction engine, you provide it with the schemas of what your model input looks like and what the model output is. And what you're able to do is you're able to provide a single instance of a model input object to the prediction engine, and then you just call the predict method, and the predict method will go ahead and return an object of model output, right? Or an object with the columns as defined by the model output schema. Okay, so that's for a single prediction. Now, one of the things or challenges with prediction engine is that it's not thread safe, right? So you might ask, okay, well, how can I build scalable applications, and how can I inference or make predictions in a scalable manner? So one of the things that you can do, and that's kind of what we're going to be doing here in this phase, is you can use the prediction engine pool. And the prediction engine pool is built to use dependency injection, which is built into ASP.NET Core. But of course, anywhere that you can use dependency injection, you can leverage this. And what it does is it creates a pool. So it creates an object pool that instantiates multiple prediction engine objects. And when you make predictions, it just picks from this pool one of those prediction engines and uses that to make predictions. And that's how you're able to get thread safety, and you're also able to get scalability. And finally, which is something that we did as part of our evaluation phase, you can make batch predictions, except in this case, you're not providing a single instance of data or a single row. What you're doing here is you're providing an entire iData view, and that way you can perform batch predictions on an entire iData view, right? And again, you saw this with the evaluation phase. Okay. So in terms of model deployment, as I was alluding to earlier in the beginning of the slide, there's multiple ways that you can deploy it. So with .NET, right? You recently with .NET 3.1, you now can use .NET Core to build WPF applications. Okay. So desktop is certainly an option. It was an option before, right, with .NET Framework, but you can certainly do it with .NET Core as well. You have UWP applications that you can deploy on the desktop. You have web services, and the web is really the place where sort of the possibilities are endless. Okay, because for web applications, there's multiple ways that you can deploy. You can deploy to an ASP.NET Core Web API. You can deploy to a Razor Pages or MVC application, just like you normally would with ASP.NET. You can deploy to Azure Functions, right? So if you need to have those serverless sort of event-based workflows, and you can certainly deploy to Azure Functions, which supports .NET as one of the runtimes. And then if you need additional scalability, right, you can have those APIs, you can have those ASP.NET Core applications hosted in a container that you can use Docker or any other container technology that you want to use to containerize or package your application and then deploy it to perhaps a Kubernetes cluster, right, where you get that sort of the ability to sort of replicate and scale your services as needed. You also have that sort of self-healing capabilities and that definition of infrastructure that Kubernetes gives you. So the web is really provides you with a lot of opportunities. And then finally, you have mobile, right? You have Xamarin. You have the latest announcement or the next version of Xamarin Forms, that unification of the .NET the desktop and the mobile apps. Okay, so mobile is definitely another target that you can use. Whether that's directly with the ML.NET, directly with ML.NET models, or again, you can leverage some sort of the native inferencing capabilities like Core ML, and because you can essentially have Onyx models, you can use those, or you can build TensorFlow models, as we'll see in the deep learning section. You can take that model that you produce in ML.NET, and you can use the core inferencing runtimes of these mobile platforms to make predictions. So again, the opportunities are endless. So, all right, let's go on to the next section. So here we are going to go through phase 3.0. And in phase 3.0, what we're going to do is we're going to load the model from a file, the file that we've saved in the previous phase, and we're going to use it inside of this web app. We're going to use Prediction Engine in this case because we want it to be scalable. We're going to use Prediction Engine pool service, and then we're just going to consume that model inside of a web page, right? And again, if you remember from the beginning of the presentation in the first couple of slides, we mentioned that the goal of this application is to predict based on specific attributes or specific features, try to predict the price of a used car. So if you follow the link at the aka.ms link, you can go ahead and see the instructions for this phase. And this one might take a while. You're not going to necessarily be doing any CSS, I promise. So I saved you that trouble. But you're just going to have to worry about plugging in the pieces that are going to allow you to inject and use this model in the application.
Are you sure we can't do any CSS, Luis? Maybe I want to do CSS.
Well, I am not a CSS master, so I'm sure there's a lot of room for improvement in making that application look nice.
I'm sure there is. Guys, if you have any questions as well on the stream here, while you're doing this, as always, just post them in the chat or in Slack, and we'll make sure to moderate them. And for those who haven't joined the community Slack yet, now's your chance. I will post a link in the chat for that. I think that the aka.ms short link may not have worked properly. So I'm posting another one in there to make sure it goes straight to the create an account page for you.
And I just noticed that the screenshot has still using version 1.4. We're going to want version 1.5 for the Microsoft extensions.ml package.
So Liz, while everyone is working on that sample as well, can you talk a bit more about the prediction engine? That sounds really cool. What is it?
Yeah, so under the hood, what it's doing is, there's no magic really. What it's doing is it's kind of creating an iData view for you so that you don't have to, because otherwise the alternative would be you would have to create an iData view. So in this case, let's say that you have a single instance of the model input object, right? So you have to create an array or some sort of IEnumerable, instantiate this object in the IEnumerable, pass in the iData view to the prediction engine, and it's not difficult. You could do it, but it's a lot of extra steps that if you're just trying to make one prediction, right, like it's not something you really want to go through, right? So it really is just like a wrapper or a convenience API, so that you yourself don't have to create the iData view. It's done behind the scenes for you. So yeah, that's essentially how that works.
Cool. And you may have mentioned already, but I think people will otherwise come across it, the prediction engine pool. What is that?
Yep. So that's higher, a little bit of a level of abstraction or one step above the prediction engine. As I mentioned, the prediction engine itself is not thread safe. So in applications where you have multiple threads accessing, being used in your applications, such as web applications, ASP.NET applications, this is something that you might want to use the prediction engine pool service, and this is an extension to it, right? And again, what the prediction engine pool service does is it creates an object pool, right? So an object pool is something that you can create in .NET, right? So it takes this object pool, and the objects that it contains are prediction engines. So I think by default it creates 50, or I forget how many it creates by default. So what happens now is anytime that it needs a prediction engine, it's not accessing the same prediction engine. It just takes one from the pool, right? So you have a pool of X amount of prediction engines that you can use, and then you minimize the risk of threads that you don't want accessing your prediction process or your prediction operation from accessing it, right?
And it sounds complicated, but it's like one line of code, right, to register that in a web app or an Azure function.
It is, yeah. You would register it just like you would in any other dependency injection scenario. So in ASP.NET, that traditionally is in your startup class. And typically that's in your configure services method, right? But you could also leverage recently Azure Functions enable the capability of using dependency injection with Azure Functions, right? So you could do that, right? So and the really nice thing about Prediction Engine Pool, there's a few things that are really nice. Number one is that you get the thread safety. The other really nice thing about it is that you have the option. So let's say that your model is deployed remotely in some server, and it's in some publicly accessible, even GitHub for that matter. And it's in some publicly accessible, at a publicly accessible endpoint URL. You're able to create a prediction engine pool from a URI. So as long as you pass in that URI and provide a URI that's publicly accessible, the prediction engine will download the model and will create the model for you. The other really cool thing about the prediction engine pool service, in addition to the fact that you can load from a URI or you can load from a file by providing the file path, is the fact that it's always checking for changes. So if you're loading it from a file, it uses the file system watcher, and I think it checks. That one's not on a time basis, but what it does is the file system watcher will literally sit there and watch the files to see if there's been any changes, and if there's any changes that are registered, it will go ahead and load the latest version of the model. Okay, so that's with files. With URLs, what it does is at a specified interval, I think it's 5 minutes by default, it's going to pull that URL, and it's going to be like, has this changed? Has the thing at that location at the URI that you told me changed? And if nothing's changed, then I just go about my business. But if something did change, the latest version of the model gets pulled down, and the benefit to that is you don't have to redeploy your application, right? Your application keeps running. It's just this polling mechanism that will upload the model without you having to take down your application and redeploy it, which is nice, right? Especially if you're in those scenarios where you don't necessarily want to have downtime specifically for your model.
Cool. And I think a question on the chat here as well is, can you use authentication? So let's say you deploy your model like a URI and you want to poll it for changes. Is there a way to do authentication on that check, I guess?
So I think that there might be a way. It not built in. So right off the bat. So for example, like let's say if you were storing this in some sort of Azure Blob Storage, right? So with Azure Blob Storage, you're able to set the permissions in terms of whether it's a private or whether you can access it with SAS tokens, so on and so forth. So by default, those are things that are not built in, right? But you could write code around it such that you can say, okay, well, if only pull this location if this user has if this user is authorized, right, to pull this location or something like that. But out of the box, no, there isn't a way to provide authentication or to use some sort of token authentication when you're loading from a URI.
Sounds like a great, I guess, improvement option as well if someone wants to contribute to a repo or open an issue. I think that's a great suggestion, I think, in my mind.
Absolutely.
And I guess there's also a way of maybe doing like a virtual private network as well, and then embedding both the URL and the app in that, I guess. So only someone within that network would be able to access that location, maybe?
Absolutely, yeah. And again, this is the example of the example that I gave was Azure Blob Storage, right, where some of that is abstracted for you. But absolutely, you can have a service that all it does is its job is solely to serve models, right? Kind of like a file server. And the authorizations and the authentication piece of that you can handle just like you would any file access sort of logic that you would otherwise place on your current files, right?
Great. But yeah, I think in addition as well, I guess, of putting it onto a file share or a public location, I guess you can also embed it into your application as well. So it never gets exposed to anything.
Absolutely, yes. You can deploy it alongside your application.
So we're getting some results here, I think, on the chat at least. Varying degrees. Some people get 0 and some people get another value as well. How are y'all doing here on the stream? I think Rutus is also asking a question here. Is it possible to change the model while the application is running, so not from the startup?
So yes, well, I'm gonna assume that the question, Rutix, maybe you can sort of like clarify this, but the way that I'm gonna answer this one is, can you use different models? So yes. So one of the things that you're able to provide with this prediction engine pool is you can give a name to your models, right? So let's say that under certain circumstances you want this particular model, or if you just want to access your model by name, you can certainly do that, right? And where this might be useful, right, is if, for example, you're running it in your application and you're inside of your controller or your action, whatever type of web app you're using or whatever app you're using. And you might say, hey, for these particular users, use this model, kind of like A/B testing type thing, right? You could do that, right? You could have different models and switch depending on some logic that you predefine, right? So you can do that not from the startup. So yes, you can.
And actually, yeah, go ahead, Ree.
Oh, I was just gonna say if we wanted to move on, but if you have another question or.
No, I just had something to add to that. If you look at Stack Overflow, there's some really good discussions right now actually about this specific topic, about changing models kind of dynamically. I think a lot of people are using it as they are like training things live in a web API and then switching it over. And there's some really cool ideas out there. I'm not sure if everything is fully supported yet, but there's some really cool ideas there. And I think it's really interesting to see how it's being used in the real world.
Yeah, and a lot of times, you know, to add on to that, that's kind of how it is, right? Like you build a technology, but in the end of the day, you don't fully take into account all the different ways and the innovative ways that people will use that technology, right? So it's really fascinating and really amazing to see what people do with these technologies.
All right, but yeah, I think we're good to move on.
Awesome. So let's move on to our review. Okay, we open this up. So first we installed the Microsoft extensions.ml NuGet package. And then we wanted to, this was saving the model. Then we wanted to define our model output. So in this case, we created this new class called model output, and what the model is going to return a score. So we had this float score. Then we registered the prediction engine pool engine service in our startup.cs file. So I'm in startup.cs in my web app, and you can see in this configure services, we added this add prediction engine pool here using the model input and output schema, and then getting the model from this file. So after that, we inject the prediction engine pool service in our index page model. So you can see here we're in index.cshtml.cs, and we have this prediction engine pool equals prediction engine pool right in our index model. And then from there, we use the prediction engine pool service in the onPost method to make predictions. So we can see we're in our same file in our onPost method, where we add this model output prediction equals prediction engine pool.predict with our input. In this case, we defined our input here, taking the input that's given in by the user, based on, and following that same schema to create that sample data point, and then predicting based on that input. And then we can show the price, which is the prediction.score. So this is, again, score is, prediction is what's returned by the model, and score is that output from the model. So this should look similar to this. I know there are a few different parts there. Oh, sorry. Yes, I can zoom in. Let me zoom into the different parts. I just saw that. So we've got our model output here, and we just created a new class for that. And our configure services in our startup.cs, we've got this, adding the prediction engine pool. And then in our index model, we've got this. And then for that last part, on post, we create that new model input based on the user input, make the prediction using the prediction engine pool and our input, and then returning that score. So I saw a few people saying that they got predictions that aren't great. They're saying, this seems too high or too low. So that's going to depend on the data set that you have. Of course, ours is just kind of a sample data set where possibly some of the cars were not represented as much as some of the other ones, like some of the maker models. So that's why the predictions may vary a lot. Louisa, do you have anything else you wanted to add about this section or about any of the comments?
Mm-hmm. Yeah, no, I did see that, and you got that spot on, Bree, that it's really going to depend. This is supposed to be more of like walking you through the steps that you would take, but by no means should you start a startup based on this model and try to cash in on it. But yeah.
Cool. All right. So let's move on to almost done with it. Well, I guess 3/4 of the way through the workshop.
Yeah.
Now it's mostly just going to be learning. We we have additional tasks that you can do, but we're not going to go through them in the workshop here. And we have links to those in our phases as well, and you can take a look at those. You can still ask questions, but I will move on to the deep learning. I think, Louise, do you want to get started with neural networks?
Absolutely, yeah. Let me just finish typing out this comment here, or I could probably just repeat the question. So the question is, you could add multiple prediction engine pools to host different models, and how would the app differentiate between different models? So these are two separate questions, but somewhat related. Again, it goes back to what I was saying before. You can name your model, right? So one of the parameters is model name as part of that prediction engine pool. So you can use that to differentiate. And then inside of your application, inside of your controller, your action, whatever it is, you can say, if whatever your condition is, choose this model or choose that model. So that's the answer to those questions. But now to get onto deep learning. So as we saw earlier in the presentation, deep learning is a subset of machine learning, right? It's all sort of like nested together. So you have AI as the bigger umbrella. You have then you have machine learning, which is, it basically learns patterns from data. And then you have deep learning. And deep learning, it's a subset of machine learning, and it typically consists of a subset of algorithms. And these algorithms are typically known as neural networks, right? So these neural networks, what exactly are they? Well, they're essentially stacked layers. You can think of them as layer, and there's these stacked classifiers that take an input, and then you can stack as many layers as you want, and then to produce an output. And the inputs for your layers are just your features, right? The inputs that you would. So in this example, it would be the make of the car, the model, the mileage, right? So those would be your inputs to your neural network, and then those get propagated through different layers until they produce the output. In this case, we want to predict a single output of the price. Okay, so this is a little bit hard to see, but if you were to think about how these things are represented or what these different layers are doing. So let's imagine the first layer starting from the bottom. In the first layer, you can see that there's nothing really legible. And here we're trying to either predict faces, we're trying to classify faces, cars, elephants, and chairs. Right? And we can see that in the base layer. Let's imagine that that's our first layer. What this layer is doing is it's deconstructing or teasing out different features or patterns in our data. In this case, it's using image data, right? So going back to the very original example when we were showing bread versus not bread, how can you determine whether it's a dog versus a piece of bread? And we show you this different if sort of statements where it was saying, if it's rounded at the top, if it's in a rectangular. Well, how would you even begin to define these things? Neural networks do a really good job at it, and typically the more layers that you have, although computing wise it may take a longer time to compute, having different layers allow you to, at a more granular level, be able to distinguish features within your data. So again, going back to this input, very first layer at the very bottom, what that's doing is it's looking at the image and it's like, okay, is there a diagonal line here? Is there like a rounded shape here? So it's trying to identify specific, very low level patterns in the data. Now, if we go up another level, taking a look at the faces in this example, you can see that now you're starting to see some more distinguishable features of what make up a face, such as a nose, eyes, ears, right? And that's just another layer in our network, all the way to the top where you can see a fully formed face. And that's essentially the output that we're trying to get to. We're trying to detect, is there a face, or what does a face look like? And again, you're able to achieve this through this stack of layers that again, very finely tease out these patterns in your data. So as it pertains to deep learning and ML.NET, there's multiple ways that you can take advantage of deep learning and deep learning capabilities within .NET. One of them is model consumption. So you can consume both TensorFlow and ONNX models with ML.NET. So, let's say that you have data scientists that you work with, or you've at some point created a model in PyTorch, TensorFlow, wherever it is, leveraging either TensorFlow or ONNX, which again provides that sort of interoperable format for these models. You can bring them into ML.NET, and you can use them to make predictions and to inference with ML.NET. Okay. So the other thing that you can do is you can do model training. So model training, if you're using the API, you can use the image classification API. And again, you can, with the image classification API, you can train custom image classification models. And you're using transfer learning to achieve this. Now, how does the image classification API work? It's built upon TensorFlow.net, and TensorFlow.net is it's a library, an open source library that provides bindings, .NET bindings for TensorFlow, right? So the API, image classification API, sits at the top of this, and it provides a really easy. It's just one method call that you would have to invoke in order to start training these models. And the image classification API supports different. We'll get into it later, but essentially, if you're using the API, you want to use the image classification API. In many instances, it's actually easier to use than a lot of other options that are out there. And then finally, you have model training in Visual Studio with the toolings such as Model Builder, right? So this works pretty much the same way, and you have the option to either train models locally, just like you would in any other scenario, right? So if you want to use your computer and you want to use your computer resources, that's always an option. And again, local is the default in many cases. But these tasks, right? Deep learning, you need a lot of compute power. You need a lot of data. You need a lot of compute power. And there was a comment earlier where it's like this training, and this was just a small data set, like 53 megabytes of data that we were using. And using a relatively classical machine learning algorithm. And the comment was, it's showing how old my machine is, right, or something along those lines. Deep learning, it's really going to show the age of your machine because it takes a lot of resources. So what do you want to do in that case, or what can you do in that case? Well, you can if you're using Model Builder, you have the ability to train on Azure. So not only is there Azure integration, it has integrations into Azure ML. That way you can inspect in Azure Machine Learning Studio. You can inspect the progress of your training progress, and again, you're able to leverage GPU-enabled instances so that it can both speed up and train these deep learning models at scale. Okay, so in terms of what type of models can you train with ML.NET? There's a few set of architectures, or very sort of state-of-the-art architectures that are supported by ML.NET, and those include MobileNet, Inception, and ResNet. Right, so you have the choice, and again, it goes back. The concept is the same as with other classical machine learning. As with other classical machine learning algorithms, right, you're going to kind of have to try these out and see which one works best for your data set. So with that, we have an additional task if you wish to try this out for yourself, kind of go through it, either both local training or Azure image training with ML.NET Model Builder. And if you go to the aka.ms phase for O, we can give you a couple of minutes to kind of look through these and get acquainted with it.
Yeah. So if you saw the .NET talk, the Journey to One .NET talk at Build, they used Model Builder with Azure training to detect car damage. So if the car was damaged or not damaged based on just an image. So that could be something that you add into this application. as an example. And I think we have a link to that. Is that right, Louise? Do we have a link to that in the task 2, to that video?
Oh, you know what? I didn't include that.
Okay, that's okay.
Yeah, but we do have your record-breaking training session where you trained a model in under 10 minutes. So, yeah.
That's true. Yeah, you can also take a look at that one. We'll answer questions as they come up. We'll give you some time to take a look at those. And yeah, we're here for questions. Looks like we have a few. Let's see. We have one that says, what are the challenges involved in adding extra classes in transfer learning? For example, if I use Model Builder to train 4 classes in image classification, but later I want to add more classes and I want to utilize the previous model with transfer learning, is this something that is possible? With Model Builder currently, you would have to retrain the entire model, and that's true for the local and Azure training. So specifically, that would be the answer for Model Builder. Anything to add, Louise?
Yeah, no, that's exactly it. So you would have to retrain the entire model to be able to do this. If you want to have access to the specific layers, right? Because I think somebody said that mentioned that these graphs, right? Because these neural networks are represented as a computational graph, and these different layers are frozen. And what transfer learning, we didn't get too deep into it, but what transfer learning does is that last layer. So if you remember the picture, that last picture that's just predicting the classes, that's the part that you're retraining. Everything else stays the same because you don't need to retrain. Like if you already learned how to identify what an ear or what a nose or what an eye is, right? There's no need for you to relearn those things. So you just retrain that last layer and adapt it to to your use case. So long story short, you have to retrain at the moment, whether you're using the API or whether you're using Model Builder. You could use TensorFlow.net, right? Because that gives you those lower level bindings to TensorFlow. So you could use that, but at the moment, yeah, it's not something that's possible in ML.NET.
Good one. Anyone else on the stream that has any questions here in this section so far? We're definitely going deep into machine learning right now. Got that joke?
Was it? Yeah, I was going to say, is that a pun?
It was a bad joke. Sorry. Being at home in quarantine for 2 months, does that to you? All right, we get a question from Likuna. At Build this year, they brought up that there were some major optimizations to model compiling, so the output is as effective as possible. Was these enhancements ported to ML.NET?
So I suspect, Lee Conan, what you're referring to there is Onyx. And the short answer to that is I don't know. But I suspect so. So the way that it works with scoring models with ML, especially with Onyx, right? What ML.NET provides you is a wrapper around the Onyx runtime. So it leverages the Onyx runtime. Now, I don't know off the top of my head which version, right? Because there's different versions of Onyx runtime that are out there. I don't know if ML.NET in its current release in 1.5 is using the latest set of the latest version of the runtime. So the short answer is I don't know, but as long as ML.NET is using the latest version or tapping into the latest version of Onyx runtime, it should be able to take advantage of these optimizations.
And you can also post that question on our GitHub, which is .NET/machine learning. And we've got the whole ML.NET team that looks at those issues. So or it'll give us a reminder to check back with the team and get that answer back for you.
And I actually see that one of our fellow presenters tomorrow, he actually just got mentioned that it's using version 1.3. So the latest version is 1.7 of Onyx runtime. Current version of ML.NET uses 1.3. So it's a little bit behind, but Yeah. So as long as, again, as long as you're able to, it eventually uses the latest version, it will take advantage of those optimizations.
Great answers.
Cool. Looks like there are no more questions right now, unless I missed one. So I guess we can move on to the next section. No tasks that we're going to go over. These are just ones that you can go over yourselves, and then if you have any questions, let us know. All right, and MLOps.
Yeah, so MLOps, you probably have heard this a lot lately. It's definitely something that's becoming more and more of a common term. So much so that Alexander has created a public repo after that name, MLOps.net. But what exactly is MLOps, right? So for everything that you can think about in terms of like machine learning in general, right? It's very experimental. It's a lot of trial and error. At the same time, there are practices and there are certain things that you can do to operationalize and standardize and bring over some of the best practices that for years have been available inside of the software engineering discipline, and you're bringing some of those practices over to machine learning, right? So MLOps, or machine learning operations, is basically the application of DevOps principles and practices such as continuous integration, continuous delivery, deployment, logging, and monitoring to the ML process. Okay, so that's essentially what that is. Now, what does an MLOps workflow look like? So actually, even before I get into that, like, why would you want to do this? Why would you want to do MLOps? What does it give you? Again, with the experimental nature, right? You want to be able to track, like, when you build a model, how did I get that model? What was the pipeline that was used? What was the data set that was used? Which version, which algorithm was used? Was there any sort of what were the performance metrics of that model? You want to be able to capture all those things because you want to know in future builds or in current builds, is my model performing better? Is it performing worse? And if so, should I deploy it? And at the very least, something that you get with DevOps, right, and your software development lifecycle, in the software development lifecycle, is at the very least, if you do nothing else, it automates your workflow. You're able to have automated tests, you're able to have automated build pipelines, and that's great. But the other thing that you get there is you get audit transparency, right? Because you know exactly, you can pinpoint back to how a particular model was built. You get auditability, right? Because you're logging or the entire process. And again, you're able to sort of, and you get reproducibility, right? Because you know how it was that particular model was built or that particular piece of software was built. You're able to go ahead and reproduce it, right? And that's important with experiments, right? With experiments, you want to be able to reproduce them. So how exactly does an MLOps workflow, or what does an MLOps workflow look like? So this is very similar to your DevOps workflow, where in your DevOps, you have your build, your test, and your deployment, right? Very similar. MLOps is the same thing, except in your build step, you have your training. And in your test, you have your evaluation. And in your deployment, it's just your standard deployment. To get into a little bit more detail, what does this mean, right? So you have the train model. You have this section here in training. You train your model. So what exactly takes place in this training phase? In this training phase, what's happening is, let's say that your code, just like in for these phases and exercises, right? Our code was in GitHub, and we had some sort of version control where that's where we're able to keep track the changes in the code. And let's say that a data scientist goes ahead and they make changes to the code. Those changes are tracked in version history, so you know which version of the code triggered a particular training run for a model, right? Now, you can either have the training or the retraining process trigger at the point when new code is checked in and you're changing how your model is trained, or you could also do the initiate or trigger the training process when there is new data, right? So you can also set it that. You can also set it up on a schedule, cadence, every month, every week, whatever it is. The point is, this is something that's automatically triggered, and there's a way to log that. Once your training is done, you go ahead and you package your model, right? So that's that saving piece. You save your model, you store it somewhere, some sort of blob storage, some file share, wherever, and you tag your model. You provide, hey, this is version XYZ of the model, right? And that allows you to track which version of the model you're working with. Once you have that, you go ahead and you validate the model. So you have some sort of set of tests. In this case, with ML.NET, right? And when we're talking about the .NET ecosystem, these tests are really as simple as just writing unit tests. So if you've written unit tests for your applications, for your desktop, web, whatever type of application, it literally is that. It's just unit tests. You can use XUnit, NUnit, whatever it is that your preferred testing framework. And some of the things that you might want to be testing for is, number one, is the accuracy above a certain threshold, right? And that's going to be dependent on how comfortable you are with the accuracy or with the evaluation metric of your choice. You want to make sure that the model is able to load. You want to make sure that the model is making the predictions as expected. So different types of unit tests that you can build into this process. And again, all of this is automated. And because you get the automated tests, you also get reports of what tests are failing. And then you're able to determine what can you do to fix these things within your model. And then finally, you have the deployment phase. And the deployment phase is exactly what it sounds like. And it's just like any other traditional application. In the deployment phase, all you're doing is you're either taking the model that you've already validated and you're saying, hey, let's put that up in some file share, and then, using something like Prediction Engine Pool, it's just going to pull the latest version of the model. Or you can embed it within your desktop or web application and redeploy that application. Again, it really varies, okay? But deployment, again, it's just the exact same things that we've been talking about through this entire session. And then finally, right, you want to monitor. You want to monitor and you want to make sure that your application is, number one, it's performing well. One of the things as part of the monitoring, and it's beyond the scope of this talk, is something called data drift, right? So you want to make sure that your data the new data that's being passed into your model to make inferences, you want to make sure that the distribution of that data is still somewhat in line with the distribution that the model was trained on. Because what happens when that's not the case is you start getting poor results, right? And you don't want that. And at the same time, this monitoring phase or this monitoring mechanism that you have in place, what that's going to allow you to do is it's going to allow you to intelligently determine, like, hey, it's time to retrain our model because it's sort of drifted from what the current environment that my application is living in, and at that point you need to retrain it and basically teach your model the new patterns that have been emerging within your application, within your use case, and what your users are doing. So with that, it was very short, but it's definitely something that you should think about as you're building your applications, something that you should think about as you are deploying your applications. There is in this aka.ms link, there are some resources, and there's also a sample project that uses ML.NET to kind of showcase these training, testing, and deployment phases of the MLOps pipeline.
That's awesome. And I think this is something that, for me personally at least, where like software engineering comes really well into play here, bringing into the software engineering kind of community with the machine learning community, because we are really good at automate things as software engineers, and we mastered DevOps pretty well, and that's something what we really push for. And MLOps is kind of the natural evolution, I guess, of those things.
Yeah, absolutely. Yeah, and that's one of the things, right? Like, folks may ask themselves, well, how can I get involved with machine learning? But I don't necessarily want to be, dealing with algorithms and math and deep learning and gradients. This is an excellent way, right? The operationalization and bringing the best practices of engineering, software engineering, to the process and building out the infrastructure to enable these training, testing, and deployment scenarios.
Yeah, and as you touched as well upon, Luis, I mean, it's many more dimensions as well than just code in normal DevOps, where you're trying to get your code out to production. As you said here as well, like we have the code and we have the configuration, we have the data, we have the model. All of them can change and trigger something changing in your predictions.
Yeah, absolutely. And one of the nice things I would say, I think there was an earlier comment that was said, like, when is ML.NET going to become mainstream? So one of the advantages of not being mainstream and sort of, having, well, ML.NET as TLC has been around for years, right? But as an open source project, and it's the ML.NET product, it's only been around for 2. These ML ops questions and these challenges, they've been solved in other frameworks like in Python and stuff like that. So from an ML.NET perspective, we get the advantage of being like, hey, this is a solved problem. They've like somebody's already done the hard work for us. Now it's just like, how can we implement that in this framework? So there's certainly advantages there that some of these problems have been solved, some of them haven't. But where we do have solutions for them, it makes it easier to integrate into ML.NET.
Absolutely, and I think Rutix, you had a question here. When you deploy the new model, will it do a hot swap of the model?
Yeah, that depends, right? So if you deploy your model as part of your application, right? So if you include it as part of your ASP.NET Core or whatever type of application, you're going to have to redeploy your application at that point. If you're doing the prediction engine pool method, right, where it's either polling that public URI or it's checking that file, that file location where your model is, then in that case, it should be able to reload it without you having to redeploy your application.
Perfect.
Cool. So if anyone has any other questions, obviously feel free to ask. I'll move on to our last phase. We have a chance for questions at the end. Make sure you check out phase 5.0 at this AKA link if you want to learn more about MLOps and see examples of it. So let's wrap it up. I'll talk a little bit about what's coming up with ML.NET. So we have text loader improvements, local AutoML support. So right now we have that for classification tasks and regression. So we want to add that for time series forecasting, anomaly detection, and ranking. So those are in the works so that those of you that don't want to have to deal with the algorithms and algorithm options, you'll be able to take advantage of AutoML. Object detection training, right now you can only consume object detection models via Onyx or TensorFlow. So in this case, you will actually be able to train object detection models. Continued expansion of our Onyx export support. Onyx is really growing, especially here at Microsoft. There's really big support and push for it. So ML.NET will also follow in those steps. And then a bit of tooling improvements. So we want to make sure that all of our local AutoML and Azure AutoML supported scenarios can be accessed via our tooling. We know right now it's very, very simple, which can be a great thing. Straightforward is great, but there's some more advanced options that might limit specific users from using our tooling. So we want to add some more advanced options. Adding GPU training for local image classification or any local deep learning tasks we have. Right now we offer support for Azure training using GPUs in Azure, but not local GPU training. So we're working on that as well. Adding reentrancy in Model Builder. So right now, there's one Model Builder session, and as soon as you exit out of that session, you lose that session. We're working to actually add reentrancy and it's a saved state to that. And then MLOps integration, that I guess should go more under ML.NET in general. Louise talked about how important it is. So we're really working to see how we can integrate best with MLOps. And then improving and simplifying CLI commands and options, and then making sure that we maintain that scenario parity through our tooling, or with Model Builder and CLI, and then local AutoML scenarios. And of course, all the feedback we get from this conference, from you all, that will help drive our roadmap as well. And we'll be able to add more and more things to this. The final thing we have is a Q&A. So this is just any final questions, anything we may have missed. I'll leave it on the resources slide so that you all can take note of all these links. We have our main landing page where you can get started. We have our samples, our docs, some videos, and then of course our GitHub. And then Louise and I put both of our Twitter handles there, so you can reach out to either of us. But yeah, so let's get some questions.
Yeah, we got questions in the chat here. Clarence, he asked if image segmentation support is also in the roadmap. I
don't believe that it is right now. So that if you want to add that to our GitHub repo, and we can start taking a look at it. Do you have any specific scenarios in mind, like that you would want to use it for? And I can let you type that out.
Yeah. The next question here, while Clarence maybe clarifying that, is what time span is this roadmap meant to be?
I was hoping that I wouldn't get that question. No, that's a great question. I would say for now we'll give it a tentative 6 months. But I can't make any promises about anything. And this could change based on the feedback that we get from everyone. But these are things, a lot of these things are already being worked on. So yeah, I could see that you think to make that question. But yeah, I would say it's more of a free form. But yeah, maybe let's say maybe next 6 months, because they are all things we're currently working on right now. So.
And again, it's an open source project, right? So if anyone wants something very deeply, then we can all kind of just jump in and do it as well.
It looks like Clarence responded and said workplace safety. Yeah, that's a great scenario. If you could leave us or file an issue on our GitHub and put that would be really, really awesome. And we can start looking into it for sure.
Awesome. So you mentioned some links here, Bree, while people are thinking about questions here. So you get started. That's going to take you to the docs, right? The tutorial, is that right?
This will just be that main landing page.
Okay.
I got the comment, Bree sounds like a PM. Well, yeah, what can I say?
That's good. Do you want to share the story from yesterday evening, Bree, when you were trying to use the model builder to train the data?
What was the story?
Well, you were trying to train a model using the data set, and it didn't create a model for you, but it was only 10 seconds that you used, right? And we're trying to get it to work, and you were complaining that this PM, she should really get this working.
Yeah, so when I first started on the ML.NET team, I was specifically working just on model builder, on the tooling. And so, that's, near and dear to my heart. But I was trying to use it last night, and I was like, it's not working. I'm not getting a model. And then, because I was only training for 10 seconds, and I was complaining, I was like, who's the PM on this? And it was just me. So, but yeah, I figured it out. I just had to increase the training time, which I knew. I was just, workshop jitters and all that. So.
There you go. And I switch on John as well here, and me into this discussion. Mm-hmm. There's any other questions as well here? Yes, and we mentioned a hackathon. There's no more info on that. It was a great suggestion. I think Ubri had it from the beginning, and we wanted to kind of collaborate and do something during the conference here, but we only can do so much. But we definitely want to do something in the future with a hackathon. I think that'd be a really fun thing to do.
Yeah, working with Louise and Alexander and John, it's been great. We were able to put this workshop together with over 700 people have signed up. So, just a 4-person team, seeing what we could do here. We definitely would like to do more stuff in the future, especially if you all are enjoying it. And based on the feedback that you all give in the end, we'll be able to iterate from there. And yeah, would love to do a hackathon and see the different projects that people can come up with. Yeah.
Maybe we will have some t-shirts at prizes.
Yeah, that's true.
Yeah, that's good. Perfect. Well, any other questions in the stream here or in the chat today so far? Has it been, useful? Has it been a good learning experience? Liquid and already says here that it was an awesome workshop, and he thanks you both very much.
Yeah, thank you all for attending. This is really, really exciting to see people really excited about ML.NET. I'm excited to continue to grow it and grow the team and the framework.
Yeah, and Samuel Ruhr, he's asking, is there already a working sample of creating a model MLNet exporting to Onyx and inferring it with WinML? You can definitely, there's definitely tons of example, I think, of exporting it to Onyx. And I do think that Ron Dagdag, he's also a Microsoft MVP. He has, I think, to look him up. It's Ron Dagdag.
Yeah. You might want to type that in there, but.
Yes, I'll type it in there.
Yeah. There's the stuff like we would definitely like to light up these it's interesting. So these feedback, right? These samples and these use cases is sort of this type of stuff that we like to feature in our docs, right? Because that's exactly what we want to do. We want you to have this one place where you're able to see the possibilities. So yeah, definitely keep providing this feedback in the repo, in the docs, and we'll try as best as possible to make sure that these types of capabilities and these types of scenarios are lit up for you to take advantage of and to learn how to do and implement in your own applications.
Absolutely. Well, thank you all for the nice comments in the chat here so far. I think it's been a hit, Bree and Louise.
That's great.
Yeah, I mean, it would have been possible without all of you guys attending, and of course, John and Alexander really spearheading this, right, and making it happen. I think it was just on a whim. It's like, hey, anybody want to put on a conference? Like, yeah, sure, let's do it.
Yeah, it's really reignited my passion. But it's cool, and then you all were like so hype about it. I'm like, yeah, it's so awesome. Like, I have the dream job of working on ML.NET, getting paid for it.
It all started with John's innocent tweet, and then I kind of dragged him into this, I think. But happy to be here with all you guys. All right. Well, it's fantastic to see all the comments, and I'm glad I guess you all enjoyed it as well. So stay tuned. I think we're going to wrap up this day here. Tomorrow is going to be a long day. I think we have 9 hours of streaming. We had like 4 or 5 today. But tomorrow is going to be 9 hours of streaming, and we have 9 speakers from 6 different continents and 5 countries. So we'll have time zones to adhere to as well. It's going to start at 10 a.m. Eastern time. And the schedule you can find on the website, and it's going to automatically adjust your time zone. So just look at that, and you will see when it starts. And I would love for you all to join in tomorrow. It's going to be so much fun, and me and John are super excited to have you all.
Yeah, it's been great so far today, and look forward to tomorrow.
Cool. Any parting thoughts, Bree and Louise?
Just thank you all for attending. It's really exciting to see that you all were able to complete the tasks and get excited about machine learning. I am in your same place where I, started with no machine learning knowledge except for my failed machine learning class that I took a long time ago. So it's really, really great to see that you're able to build things and be excited about it. So looking forward to tomorrow for sure.
Awesome. Well, with those parting words, thank you, Bree. Thank you so much for today, everyone. Join into the community Slack. We'll keep the discussion going there, and we'll see you all tomorrow. Thank you very much. Goodbye.
Thank you all.